Night over Mauna Kea, Hawaii. The domes of the W.M. Keck Observatory gleamed under thin cloud bands, their silver shells open like eyes that never close. Inside, a beam of light struck a sensor cooled to near absolute zero, recording a sequence of images that by every expectation should not have existed. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, let me know in the comments where you're listening from and what time it is right now where you are. Not because the cameras malfunctioned, not because the data were classified, but because what they revealed was something that shouldn't be there, something that didn't fit inside the tidy boundaries of known astrophysics. The file name was unremarkable: Keski 3 Atlas 2025 089.dat. But within those digital traces lay a quiet revolution. The object was first catalogued by an automated survey telescope as a faint, slow-moving dot in early spring of 2025. It was given a simple designation 3I Atlas, meaning it was the third confirmed interstellar object ever detected. The first had been Oumuamua, discovered in 2017, an elongated shard of rock or metal that tumbled through our solar system faster than any asteroid should. The second was 2I Borisov in 2019, a true comet complete with streaming gases, whose behaviour reassured astronomers that not every visitor from the stars needed to be a mystery. But then came this one, 3I Atlas. When scientists at Keck pointed their twin 10-metre mirrors toward its faint glimmer, the first spectra they received triggered confusion, then disbelief. The data were messy, full of unexpected emission lines, chemical fingerprints that made no sense. Someone checked the calibration lamps. Someone else suspected a cosmic ray strike. They repeated the exposure. The signal persisted. The pattern was real. For nearly 2 centuries, astronomy has relied on the simple faith that nature is consistent. Given enough time, every mystery resolves into a natural process. But sometimes the data whisper a different story, one that sounds almost impolite to tell aloud. Among those who refused to look away from that whisper was Dr. Avi Loeb, an astrophysicist from Harvard, known equally for his precision and his heresy. Loeb had already angered half his field 8 years earlier by suggesting that Oumuamua, the first interstellar object, might not have been a rock at all, but something constructed. Not an alien spaceship, but a technology, perhaps debris from a long-dead civilization, thin as a solar sail, moving not by fuel but by light. That suggestion had earned him mockery headlines and invitations to conferences he never attended again. Yet here he was once more standing at the edge of the same abyss of wonder, staring into new data that seemed to echo his old suspicion: something out there was behaving with intention. 3I Atlas was different from any comet observed before. Its orbit was retrograde, moving against the current of the planets. Its angle of approach lay almost perfectly within the plane of the solar system, a statistical coincidence so rare that probability models called it less than 1 in 500. And now the Keck Observatory had found something even stranger. The object was venting a compound that didn't belong in nature at all. The night the discovery was confirmed, the observing team fell silent. Outside the dome, the trade winds rattled through the volcanic gravel. The stars over Hawaii shimmered indifferent ancient. Inside, a few words were exchanged in the stillness of fluorescent light. Nickel. Without iron, someone whispered. A pause. That's impossible. The universe, however, didn't seem to care about impossibility. Loeb received the raw spectroscopic data a week later. He studied it line by line, photon by photon, through sleepless nights in Cambridge. The numbers were unambiguous. Every known comet, every grain of cosmic dust ever analysed carries nickel and iron together forged side by side in the crucibles of supernovae. Finding nickel without iron was like finding salt without sodium or water without hydrogen. It broke chemistry itself, and yet there it was. The Keck dataset wasn't just showing nickel, it was showing a specific molecule nickel, tetracarbonyl NeCO4. On Earth, that compound exists only under industrial conditions. Human refineries use it to purify metal. It's toxic, volatile, and exquisitely artificial. No known comet, no known natural process could produce it. The Keck team was cautious. Their paper used careful phrasing: anomalous nickel emission detected, potential exotic mechanism not yet identified, the language of scientists who prefer mystery to mockery. But Loeb was more direct. When a journalist from the New York Post asked him what he thought, he said plainly, "There is only one place nickel tetracarbonyl is known to exist in industrial processes." That sentence rippled through the scientific community like a minor earthquake. Online forums filled overnight with arguments. Space agencies issued quiet statements, reminding readers that extraordinary claims require extraordinary evidence. Others dismissed the observation as contamination or instrumentation error, but nobody could explain why the signal appeared in repeated measurements across multiple wavelengths from multiple telescopes. Meanwhile, Loeb began constructing a timeline. If 3 Atlas had travelled through interstellar space for millions of years, it had somehow preserved this compound intact. That alone was stunning. Nickel tetracarbonyl is fragile, breaking apart in sunlight. For it to survive in the vacuum of deep space implied constant replenishment, like a factory still operating after its builders were gone. It was as though the cosmos itself had become a machine continuing a process whose purpose we no longer understood. And yet, the data didn't lie. Around the world, observatories turned their mirrors toward the same faint light, each trying to prove or disprove the finding. The results came back the same. Nickel, yes. Iron, none. The chemistry of industry, not of nature. Somewhere between the stars, something was working. When Loeb wrote about it in his lab's private blog, he added a line that never appeared in the media. If this is real, it means we're not observing a comet. We're observing a process. It's easy to dismiss such thoughts as sensational. But the truth is, science begins exactly where comfort ends. The people who first saw the Earth curve under their ships thought their instruments were broken too. That night, the Keck Observatory's twin domes closed against the dawn. The mountain air shimmered pink above the Pacific. In their data logs, 1,000 photons waited quietly, evidence from across light years, patient and indifferent. No announcement was made, no press release. Just a folder on a server in Hawaii containing proof of something that defied every rule we'd written for the universe. A comet that shouldn't exist. A chemical that shouldn't be there. And a question humanity has never learned to ask without trembling. What if we're not alone, not in life, but in technology? The story of 3I Atlas was just beginning. The chemistry that defied cosmos. In the sterile quiet of the Keck control room, the line appeared on the monitor again, thin, sharp, and impossibly bright. A wavelength that belonged to a molecule no comet had any business producing. Nickel, yes, but not metallic nickel, not the simple elemental kind born in the hearts of stars. This was nickel tetracarbonyl, NiCO4, a molecule with a story so human, so industrial that its presence in the vacuum of space felt like finding a factory's exhaust drifting between the planets. For centuries, astronomers have read the universe through light. Split a beam through a prism, and you can read creation itself, the stripes and bars that tell you which atoms are present, how hot they burn, how fast they move. And for nearly every object ever studied, from distant stars to meteorites that landed on Antarctic ice, the fingerprints of iron and nickel have always appeared side by side. They are cosmic twins, born together in the collapse of massive stars forged in the thermonuclear fire of supernovae. Every blast of a dying sun blends them in roughly equal measure, scattering them through the galaxy as the seeds of planets, moons, and meteors. Wherever you find one, you find the other. So when Keck's spectrograph detected nickel without iron, it wasn't just surprising, it was chemically absurd. To make matters stranger, this nickel wasn't appearing as dust or metallic vapor, but in the form of a complex compound, 4 molecules of carbon monoxide bound to each atom of nickel. On Earth we call that nickel tetracarbonyl. It's a colourless deadly gas, an engineer's miracle and a chemist's nightmare. Discovered accidentally in the late 19th century by the Scottish chemist Ludwig Mond, the molecule changed industry forever. Mond was refining nickel ore when he noticed a strange reaction. When he exposed impure nickel to carbon monoxide gas, at low temperatures the metal seemed to vanish. What he'd created was a vapor nickel tetracarbonyl that, when heated again, decomposed into pure nickel and carbon monoxide. It was the birth of the Mond process, a method that remains one of the most precise metallurgical purification techniques ever invented. In the controlled conditions of an industrial plant, it's elegant chemistry. In the middle of interstellar space, it's an impossibility. The process requires exact conditions, pressures near 1 atmosphere, temperatures around 50 degrees Celsius, an abundance of carbon monoxide gas, and a source of refined nickel metal. It's as far from natural cometary chemistry as an assembly line is from a volcano. Yet 3 Atlas was producing this gas by the gram every second. The Keck team double-checked. They cross-referenced their data with spectrographic libraries of every known molecule observed in astrophysical contexts: silicates, carbonates, sulfides, even exotic organics found in the tails of other comets. Nothing matched except NISO 4. The spectral lines at 223 nanometers, 258.9 and 347.5 were precise, no ambiguity, and the ratio was exacting 4 molecules of carbon monoxide for every atom of nickel, a stoichiometry so precise that it implied control, not chaos. Maybe one of the younger researchers offered during a midnight session, there's some unknown photochemical process happening. Sunlight breaking down compounds on the surface and recombining them. The senior chemist shook her head. At those temperatures in that vacuum, no chance. You'd need pressure and equilibrium and a feed of carbon monoxide gas. None of that exists out there. They all knew it. They were looking at a signature that did not belong to nature. And yet in science, disbelief is not enough. It has to give way to explanation or to wonder. Avi Loeb understood that. When he examined the data, he didn't start with panic or excitement. He started with curiosity. What if the laws of chemistry weren't broken but applied? What if somewhere something was using chemistry the same way we do deliberately? He pointed out a quiet detail. Most reports overlooked. Nickel tetracarbonyl isn't just industrial, it's functional. Engineers use it to coat metals to create corrosion-resistant surfaces to produce high-strength alloys for aerospace and electronics. It's a molecule of design, not waste. To Loeb, that fact mattered. If this were natural, he wrote, we'd expect random ratios, unstable intermediates, transient compounds. But we're not seeing that. We're seeing order, process, purpose. In other words, the kind of chemistry that means something is being built. Still others weren't ready to follow him there. The European Southern Observatory released a cautious memo. While the compound's spectral signature is consistent with nickel tetracarbonyl, further confirmation is required. Natural explanations should not be dismissed prematurely. Natural explanations, the eternal refuge of scientists standing on the edge of a cliff. But every telescope that turned toward 3I Atlas in the weeks that followed saw the same spectral line. From Hawaii, from Chile, from Spain, even from small amateur observatories using high dispersion diffraction gratings. The same chemical fingerprint echoed across the world's instruments, a whisper from the stars saying, "You've seen this before, but only in your factories." The data were public, the math unyielding. A comet was producing an engineered molecule. What did that mean? Perhaps nothing. Perhaps there was some hidden geochemical mechanism, nickel reacting with trapped carbon monoxide under unknown pressures inside the object's core. Maybe a rare combination of solar heating and rotational dynamics created pockets where such chemistry could occur. But if that were true, it should happen elsewhere too. There should be other comets doing it, and there aren't. In the whole catalogue of observed comets, hundreds of them studied across a century, this had never appeared. Not once, not even as a trace, only here, only now. As the discovery spread through astrophysics circles, the tone shifted from denial to fascination. Younger researchers, less invested in orthodoxy, began to whisper in lab corridors, what if Loeb's right again? In a university seminar, a planetary chemist tried to reframe the unease. Maybe the question isn't whether it's artificial. Maybe it's what artificial even means when the universe has had billions of years to learn how to imitate us. The remark earned a nervous laugh, but it stayed with people. Because whether the process was alien, automated, or purely natural, 3 Atlas was teaching humanity a new lesson, that somewhere out there the distinction between nature and technology might already have blurred. On the graphs, the emission lines continued to pulse a faint heartbeat, from deep space, regular, mechanical, unexplainable, a machine's breath drifting under sunlight, the chemistry of intent, the comet that breathes backwards. By mid-July 2025, astronomers around the world began to notice something else, something that made even the strange chemistry of 3I Atlas feel almost ordinary by comparison. The comet was breathing in the wrong direction. In every textbook, in every diagram of a comet since Edmund Halley's time, one principle stands untouched. A comet's tail always points away from the sun. Always. The solar wind, a stream of charged particles racing outward at nearly 500,000 miles per hour, strips gas and dust from the comet's surface, pushing that material into long luminous arcs. Radiation pressure adds to the effect, sunlight itself acting like a wind of photons. No matter where the comet travels, its tail follows that invisible gale flowing outwards, a banner of ice turned to vapour. But the Keck Observatory's cosmic web imager captured a scene that violated that law of nature in the most elegant way imaginable. 3i Atlas possessed a plume, a dense, narrow stream of material extending hundreds of kilometres, not away from the sun, but toward it. It was like watching a candle's flame bend down instead of up, a breath drawn toward fire instead of away from it. When the first images circulated among observatories, most astronomers assumed a calibration error. A mirrored image, perhaps an orientation flipped during processing. Yet subsequent sessions taken days apart and in different wavelengths confirmed the same geometry. The plume pointed sunward, unwavering, deliberate. At first glance, the composition appeared ordinary enough, roughly 87% carbon dioxide, traces of water, vapor cyanide, and the now familiar signature of nickel tetracarbonyl. But its direction defied every physical intuition. To understand why, picture the sun not as a distant ball of fire, but as a constant hurricane of plasma. The solar wind, mostly electrons and protons, streams outward in all directions. As those particles strike a comet's escaping gases, they ionize them, sweeping them outward into space. Radiation pressure from photons does the same to dust. That's why every comet, from tiny Enki to mighty Hale-Bopp, displays a tail that flows away from the sun even when moving outward or inward. It's the simplest, most predictable rule in comet physics. Except here the rule was broken. The Keck team triple-checked the geometry. The sun was here. The comet was there. The plume went the wrong way. When the data reached Loeb, he studied it in silence. Then during an interview weeks later, he summarized it in the simplest of terms. Comet tails don't point at the sun. Ever. This one does. It wasn't just direction, it was stability. The plume maintained a constant orientation even as 3i Atlas rotated. That meant it wasn't being blown by external forces, it was being projected, a continuous directed emission like exhaust. In a normal comet sublimation, the process where ice turns directly into gas occurs unevenly across the surface. The side facing the sun heats first, vents vigorously, and those gases are then pushed backward, creating gentle thrust that can alter the comet's path slightly. But in this case, the hot side was emitting toward the source of heat, like steam pushing into fire. Astronomers proposed explanations. Some suggested the jet was simply an anti-tail, an optical illusion, caused when the Earth's viewing angle lined up perfectly with a narrow stream of dust in the comet's orbital plane. Others proposed rotational precession, a kind of wobble causing a periodic reversal of orientation. But the data didn't fit. The plume's motion was linear, coherent, and sustained. That left a possibility most scientists refused to speak aloud in tension. If the emission were controlled, it could serve a purpose, perhaps stabilizing the comet's rotation, or even altering its orbit. In engineering terms, it looked less like a tail and more like a thruster burn. Amateur astronomers, always the boldest theorists, began producing models, a continuous jet producing minute but measurable delta-V changes, a possible perihelion maneuver. One analysis from a Chilean observer calculated that if the jet maintained its output for just 20 days, it could adjust 3i Atlas's trajectory by hundreds of kilometers, enough to fine-tune a planetary flyby. It was the kind of speculation that professional scientists avoided in public, but quietly calculated in private. Avi Loeb didn't avoid it. In an interview with Scientific American, he said almost offhandedly, the jet's orientation is consistent with controlled thrust. We're not talking about science fiction, we're talking about physics. To anyone else, it might have sounded outrageous. To Loeb, it was simply the logical consequence of data. Meanwhile, spectroscopic readings revealed that the gas composition within the plume fluctuated, rhythmically pulsing every few hours, as though something beneath the surface was cycling, opening, closing, modulating output. A comet breathing. Across observatories, scientists debated, could an internal pressure build-up perhaps caused by pockets of frozen CO2 vent, periodically, as the object rotated, possibly. But such venting should still obey the direction of the solar wind. This didn't. And so, in late July, when Keck released a new composite image, a high-contrast rendering showing the plume as a glowing spear of light stretching directly into the solar glare, the silence that followed wasn't disbelief anymore. It was the silence of minds crossing the threshold from skepticism to wonder. because in that single image, 3i Atlas ceased to look like a piece of drifting ice. It looked driven. In the language of physics, momentum was being transferred. In the language of human imagination, something was steering. Across the endless black, an object from another star was pointing its breath toward the very light that should have destroyed it, like a creature whispering secrets into the furnace of creation. And as Loeb would later remark in the understated tone of a man who had spent his life looking for meaning in silence, it doesn't look random. It looks controlled, like a thruster. The Mars flyby no one saw, October 3rd, 2025. Mars hung low on the eastern horizon, rust-coloured, familiar, photographed a million times. On that morning, it should have been history's most closely observed planetary encounter, an interstellar object 3 Atlas, sweeping within 90,000 kilometers of the Martian surface. Every instrument humanity had placed in orbit around the red planet was awake and ready. NASA's Mars Reconnaissance Orbiter, MR, a 16-year veteran still carrying its powerful high-rise camera, had been retasked weeks in advance to image the flyby. The European Space Agency's Trace Gas Orbiter, TGO, was positioned to study the chemical trail the object might leave in the thin Martian atmosphere. China's Tianwen-1, with its high-resolution survey imager and radar sounder, stood ready to provide triangulated data from the far side. And the UAE's HOPE orbiter, though designed for atmospheric science, had adjusted its orbit for visual tracking. In short, 4 space agencies, thousands of engineers, and an entire planet's worth of curiosity were aimed at a single point in space. For weeks leading up to the encounter, public anticipation built like a slow tide. News outlets ran animated simulations of the object streaking past Mars scientists pointing, with laser pens at trajectories, reporters framing the event as the most important astronomical close-up of the decade. Hashtags trended, live streams were scheduled, amateur astronomers tuned their scopes. For once, the world seemed united in a moment of cosmic suspense. Then nothing. The data release came 2 days later. ESA published a short press statement. Trace Gas Orbiter successfully completed observations of 3 Atlas during its periapsis pass. Preliminary imaging data under review. Attached were 4 thumbnails, dim, grainy frames that looked like smudged dust against the Martian sky. The file size of the raw images was under 1 megabyte. NASA followed hours later, releasing what they called a processed composite from MRO's high-rise camera. To the untrained eye, it was barely more than a fuzzy grey streak resolution so low it could have been taken by an amateur telescope on Earth. A note at the bottom read, "High saturation due to unexpected signal reflection. Full dataset pending calibration." Tianwen-1 released nothing at all. The UAE's HOPE team tweeted a simple line, "No significant detection." And just like that, the most anticipated astronomical event in years evaporated into silence. The internet reacted as only the internet can, with disbelief, sarcasm and fury. On Reddit's astronomy, the top comment read, "So NASA put $1 billion camera around Mars and took pictures that looked like they were shot through a potato." Memes exploded across X, and TikTok images labelled "Mars through Vaseline" and NASA's new anti-focus technology went viral. One viral post showed a blurred grey blob captioned, "Artist's Impression HD." Another displayed the classic 1970s Face on Mars photo next to the 3i Atlas blur with the tagline, "Different decade, same focus problem." But behind the humour ran a sharper tone frustration. Because everyone knew what the high-rise camera could do. Its optics are legendary, capable of resolving objects as small as a coffee table from orbit. It had photographed parachutes from descending rovers, tyre tracks on Martian dunes, even fragments of meteorites glinting under thin sunlight. And now, when the most extraordinary visitor in recorded history passed by, it somehow managed to capture nothing but fog. Scientists tried to explain. The geometry was difficult. The object's relative speed, nearly 70 kilometers per second, made tracking complex. Exposure times were too long, lighting conditions imperfect. Yet not everyone was convinced. Independent data analysts pointed out inconsistencies. The release timestamps didn't align with the known trajectory. A few frames appeared cropped, their coordinate metadata stripped. Why are there missing minutes? Asked one thread on a professional astronomers forum. Where's the high-res sequence MRO was scheduled to capture NASA's official response, came through its Planetary Science Division director, Our instruments were challenged by unexpected brightness variations and angular velocity. We'll share further imagery after analysis, but weeks passed and nothing new appeared. Meanwhile, those who compared the blurred images with pre-event simulations noticed something uncanny. Even in degraded form, the light signature seemed elongated, almost structured. Some insisted it hinted at shape, others dismissed it as noise. Still, the silence from agencies only amplified the noise outside them. For years, Mars had been the most photographed object beyond Earth. Every rover, every orbiting platform, every amateur telescope had turned its lens toward that red world. And yet, on the one day the universe sent something to Mars, a messenger from another star, our collective vision went blind. A few scientists speculated cautiously that data might have been withheld for calibration or verification. Others suspected misalignment with the object's true trajectory, an error caused by its peculiar sunward jet. But the public mood had already shifted from curiosity to cynicism. Across social feeds, one question began to echo: where are NASA's real images? In chat rooms and late-night podcasts, the phrase took on a rhythm, a whisper of discontent that felt almost familiar, like the murmur that followed the Apollo 20 denials, the missing frames from the Viking lander archives, the blurred edge between open science and quiet control. Maybe the images existed and were simply poor. Maybe they didn't. Or maybe, as some quietly wondered, they showed more than anyone was ready to release. For now, the official record of humanity's closest look at an interstellar visitor near another planet consisted of 4 blurred photographs, each more ambiguous than the last. A visitor passed within a cosmic inch of our robotic eyes, and somehow we blinked. The global silence. For the first time in decades, 4 rival powers, each orbiting the same distant world, seemed to speak with one voice, and that voice said nothing. In the weeks following the October 3rd flyby, no new images of 3i Atlas emerged. No press briefings, no updated orbital plots, no color composites from HiRISE or TGO. The most watched object in the solar system had passed within sight of a dozen functioning cameras, and yet the world was told that every one of them had somehow failed to capture anything usable. It wasn't the first time data had been delayed in planetary science, but this was different. Each space agency has its own rhythm of disclosure, its own bureaucratic heartbeat. NASA traditionally releases raw images within hours. The European Space Agency prefers internal review first. China's CNSA often publishes after weeks of internal analysis. The UAE's HOPE mission built largely for educational outreach streams data freely. They answer to different governments, different politics, different expectations of transparency. And yet after 3i Atlas passed Mars, they behaved as one organism's synchronized silence. Inside, NASA's Jet Propulsion Laboratory image data from the Mars Reconnaissance Orbiter would normally flow through a well-established pipeline. The HiRISE team at the University of Arizona receives raw telemetry corrects, distortion adjusts for instrument gain, and publishes calibrated products to the planetary data system. That process typically takes days, sometimes weeks. But the raws, the unfiltered images, are usually available immediately. This time, they weren't. Every query to the archive returned the same placeholder text data under review. Release pending mission operations approval. At ESA's mission control in Darmstadt, similar phrasing appeared in Trace Gas Orbiter's log, data embargoed pending consortium validation. China's National Space Administration offered only a single line on its public portal. Scientific results will be released after multi-agency analysis. And the UAE's HOPE mission, usually eager to share Martian clouds and dust storms with the public, quietly redirected its latest images tab to a generic status page. It was as though a curtain had fallen across the entire planet. No agency accused another. No public disagreements surfaced. For once, there were no leaks, no anonymous engineers sharing files with journalists. Instead, there was the eerie stillness of institutional discipline, the kind that feels less like chaos and more like choreography. To understand that choreography, you have to know how space data moves. It doesn't travel like a photograph on your phone. Every pixel that leaves a probe must pass through verification layers, telemetry, decoding integrity checks, formatting for proprietary databases. Before any scientist can even open a file, administrators must confirm its chain of custody. And if something anomalous appears, something unanticipated or ambiguous, those layers multiply. Suddenly, the data belong not just to scientists, but to committees, Each committee has to write a memo. Each memo has to be cleared by communications offices. Every line of public phrasing must pass legal review. In most cases, this is about accuracy, not secrecy. Space agencies live or die by credibility. A premature claim, especially one bordering on the extraordinary, can damage years of trust. That's the innocent explanation. But there is another quieter pattern in how such systems behave. When multiple agencies with different governments and languages begin to mirror one another's caution, it suggests not collusion, but coordination. Not a conspiracy of silence, but a consensus of uncertainty. Behind the scenes, science becomes diplomacy. The European Space Agency relies on NASA's Deep Space Network to transmit data. NASA, in turn, shares planetary navigation data with China's Tianwen mission, under existing cooperative accords despite political tension. The UAE's HOPE mission depends on US suppliers and software. Their independence is limited by bandwidth, by contracts, by habit. If one partner hits pause, the others do too. That's how global science works, an ecosystem where caution spreads faster than truth. Still, there were whispers. A planetary scientist in Madrid mentioned in a private forum that the embargo came from higher up than the instrument teams. A Chinese astronomy blogger noted that Tianwen's telemetry file count dropped to 0 exactly 12 hours after the flyby an event that had never happened before. And in Houston, a journalist for Nature received a short email from an unnamed NASA employee. "We got more than we can explain." The message was deleted within an hour. By late October, even professional scientists had stopped expecting new data. Conference abstracts about the 3 Atlas encounter quietly disappeared from online schedules. The topic became impolite to mention in briefings, and the silence itself began to acquire weight like a planet exerting gravity. People who had spent their lives studying dust and spectra now found themselves studying absence. The missing became the data. Some theorize that the agencies were protecting one another, coordinating to avoid public panic. Others argue the opposite, that they were shielding themselves from embarrassment, concealing the failure to record anything useful. A few even suggested a technical malfunction triggered across multiple spacecraft by the comet's own emissions, though none of the official telemetry supported that claim. Whatever the reason, the result was the same, a moment of shared blindness written into the record books of every spacefaring nation. And beneath the surface a quiet unease, because if the images were simply poor, they could have been shown. If the spectra were inconclusive, they could have been released. If the data were corrupted, they could have said so. But instead, the world's most advanced cameras, operated by competing nations across millions of kilometers, all chose silence together. It was not the silence of ignorance, it was the silence of knowing. Somewhere in the red dust between planets, something had passed, and the institutions built to study the cosmos decided for now to look away. No declarations, no leaks, no drama. Just the calm, deliberate hush of global consensus. Not conspiracy, coordination. And in that coordination lay the first real mystery of 3 Atlas, not what it was, but why so many all at once decided not to see it. When backyard telescopes saw too much, it didn't begin in a laboratory. It began in a backyard. A small Portuguese town called Evora, whitewashed walls, olive trees, and one man who refused to sleep while the sky was clear. His name, or at least the one the internet knew him by, was Dobsonian Power, a nickname born from the telescope he had built himself 15 years earlier from scrap metal and patience. The kind of person who could sand an optical mirror for weeks until it sang with starlight. To most people, he was just another obsessive hobbyist. But within the global astrophotography community, he was known as the quiet craftsman, who could coax galaxies out of suburban light pollution. He had posted deep-field images of Andromeda that rivaled professional observatories' moon mosaics, sharp enough to count boulders in craters, and planetary captures that made it into astronomy magazines. He wasn't a crank. He was meticulous, the kind of amateur whose measurements professionals sometimes borrowed when calibrating their own. On the night of October 7th, 2025, while the agencies stayed silent, he pointed his home-built 400-watt telescope at a patch of sky just beyond Mars. His rig was a Frankenstein of precision, a modified CCD camera, adaptive optics, and a cooled sensor rigged from a retired security camera. He knew the coordinates. He'd been following the object for months. That night he caught it. A faint speck moving against the background of stars at just the right speed, the ghostly trace of 3i Atlas now receding from its Martian encounter. He stacked hundreds of frames, aligning them by motion instead of by stars. Then he applied his usual toolkit dark frame subtraction wavelet sharpening and a custom AI enhancement algorithm trained on deep sky datasets. And in the final image, when the noise cleared, something took shape. It wasn't much, a hint of geometry, an angular shadow inside the halo of reflected sunlight. Not round, not random, but triangular, like the edge of a facet catching the light. He stared at it for a long time. He checked his processing logs. No artifact matched that pattern. No pixel error behaved like that. He repeated the stack. Same result. At 3:14 AM, he uploaded the image to his forum with a simple caption: New stack 3i Atlas. Structure. Within hours, the internet was awake. Threads exploded across Reddit X and amateur astronomy servers. People zoomed in, outlined the triangle in red, overlaid it with previous data from Oumuamua. Some saw smooth lines, others saw machinery. A few insisted it was simply overprocessed glare. But the image had that peculiar quality that makes human brains itch. Just enough order to feel intentional, just enough blur to invite imagination. That's when the algorithms joined in. AI upscalers, the kind used by enthusiasts to enhance blurry videos, began circulating. Each version sharpened the geometry further, smoothing the noise, reinforcing edges, turning faint gradients into clean angles. The human mind filled in the gaps, the machine mind confirmed them. By morning, the triangle had become a shape, a craft, a structure, a thing that might be built. Comment sections swelled with speculation. Some users claimed to see repeating panels, struts, even a faint exhaust line. Others argued it was pareidolia, the brain's ancient instinct to find faces in clouds, predators in shadows, meaning in static. Psychologists call it apophenia, pattern. Recognition gone wild, the evolutionary side effect of being a species that survived by noticing the almost imperceptible. In the flicker of a savanna's grass, it once meant life or death. Now in the flicker of digital noise, it meant hashtags and hysteria. But amid the chaos, one thing stood out. Dobsonian power never claimed more than what he saw. He posted again, quietly. I don't know what it is, but I've photographed comets my whole life. None ever looked like this. That sentence travelled faster than the image itself. Within 24 hours, astronomy YouTube channels had turned it into breaking news. Analysts drew diagrams comparing it to orbital debris, to the James Webb segmented mirrors, even to theoretical light sails. Memes followed triangles over Mars triangles in the sky triangles, with Loeb's face photoshopped in the centre. And then just as quickly the footage started disappearing. First from his forum, then from the video mirrors that had copied it. Links broke, posts redirected. He wrote a final update. It's fine. I've been contacted. They just wanted the originals. He never said who they were. His profile went inactive 2 days later. The copies survived, of course, the internet never truly forgets, but every re-upload looked a little worse, a little more compressed, until the image became exactly what most astronomers said it always was: noise. Only this time the noise had a shape, a geometry that refused to vanish completely like a watermark burned into the collective imagination. Perhaps it was nothing more than artifact and coincidence, a flicker in the algorithmic mist, a trick of human eyes yearning for meaning. Or perhaps, as one quiet commenter wrote beneath the final surviving post, sometimes noise isn't just random. Sometimes it's the universe whispering in a language we don't yet know how to read. The debate burned for weeks, then faded like everything online does. But for those who had seen the original uncompressed version, for the handful of night watchers who had spent their lives studying specks of light, there remained a single, uneasy feeling that for one brief moment a man with a backyard telescope had seen too much. Noise shaped like meaning. The algorithmic silence. By the second week of October 2025, the noise that had consumed the internet began to fade, not in anger or exhaustion, but in a way that felt almost mechanical. At first it seemed normal. A few broken links here, a missing thumbnail there. Dobsonian Power's thread vanished from the astronomy forum with a standard message: post-removed content under review for verification. His YouTube mirror displayed a grey box reading "Video unavailable." This video has been removed for violating community guidelines. No specification, no human explanation. Within 48 hours, the same fate met hundreds of reposts. Hashtags related to Through Atlas began returning. No results found. Entire discussions dissolved like frost in morning sun. The web's infinite memory had suddenly developed selective amnesia, and yet there were no grand takedowns, no visible censorship campaigns, only the gentle, algorithmic hum of a system quietly tidying itself. It happened slowly enough that no single person could point to the exact moment when the silence began. It was like watching a fog roll. In one moment the landscape was full of voices, the next it was only the soft static of disappearance. To understand what followed, you have to imagine the internet as it truly is not a library but an ecosystem. Billions of signals, each alive, each feeding on attention. Algorithms act as its weather systems, shaping what we see and what fades away. They do not think, they react. When something attracts too much engagement too fast, especially something uncertain, polarizing, or unverifiable, it triggers what insiders call the containment reflex. At YouTube, automated systems detect surges in watch time linked to controversy. They throttle reach, suspend monetization, and route new uploads into delayed review queues. X, formerly Twitter, re-ranks related hashtags to minimize misinformation clusters. Reddit's moderation bots scan for key terms associated with external misinformation events and quietly shadow hide posts. No human presses a red button. It's all code. Code designed to protect users from panic platforms from liability and investors from volatility. In theory, it's a form of hygiene digital antibodies cleaning up the body of the web. In practice, it feels like reality itself being rewritten by an invisible hand. By October 10th, the silence had matured into full suppression. Search results for 3i Atlas, Marsfloby dropped by 90%. Most major social networks treated it as a non-topic. News outlets moved on to terrestrial politics. And yet, behind the curtain, analytics told a different story. Engagement data leaked from one platform showed millions of blocked impressions, the audience still trying to look, the system refusing to show. People noticed, of course. They always do. At first came the complaints. Why can't I find the video anymore? Why is my post shadow banned? Then came the speculation maybe the governments had intervened, maybe the platforms had been warned. But the truth was simpler and in a way stranger. No one had to tell the algorithms to silence the story. They'd learned that silence themselves. Machine learning models trained on years of crisis data had evolved a pattern when uncertainty spikes faster than verified information suppression minimizes chaos. The code doesn't care what's true, it only cares what's unstable. And so the image of the triangle, the amateur astronomer's name, the debates and diagrams all fell into the same digital event horizon. Online forums became ghost towns. A few stubborn accounts kept posting screenshots only to watch them vanish minutes later. Videos re-uploaded under different file names were flagged within seconds. AI moderation was faster than human curiosity. Even Loeb's name began to trigger automatic demonetization for creators who discussed his earlier artificial origin theories. Science channels stopped mentioning 3i Atlas altogether, not by order, but by exhaustion. When every upload turns yellow, when every discussion costs you income, silence becomes self-preservation. The world didn't decide to stop talking about 3i Atlas, it simply learned not to. It was in its own way beautiful, a new kind of natural selection. Like an immune system responding to an unknown virus, the digital world neutralized a disturbance too complex to process. The signal wasn't deleted, it was diffused. Noise turned back into static. Sociologists of technology would later describe it as the Great Containment of 2025, a case study in how global information ecosystems regulate ambiguity. The algorithms had no ideology, no orders, no conspiracy. They simply did what they were built to do, preserve equilibrium. In a sense, the internet had performed the most human act imaginable. It had looked at something it couldn't understand and quietly turned away. By mid-October, even searches for Dobsonian power returned nothing useful. His channel gone, his archives scrubbed. A lifetime of night skies erased by a few automated lines of code. The story of the backyard astronomer became an offline rumor traded in encrypted chats and voice messages that ended with the same shrugging phrase, "It's probably nothing." And maybe it was. Maybe it was just the system protecting us from our own uncertainty. Maybe it was proof that even algorithms feel fear not of monsters or governments, but of meaning itself when it begins to slip beyond control. The digital tide had rolled out, leaving only silence behind. A silence so even, so seamless, it almost sounded natural. Not the silence of conspiracy, the silence of code. The physicist who wouldn't stay quiet. In every era of science, there are a few voices who stand apart not because they reject reason, but because they insist on following it farther than comfort allows. For the story of 3i Atlas, that voice belonged to Dr. Abraham Avi Loeb. To the uninitiated, Loeb's resume reads like the quiet biography of an establishment scholar, former chair of Harvard's astronomy department, founding director of the Black Hole Initiative, member of the President's Council of Advisors on Science and Technology. A man who has spent decades teaching gravity relativity and the formation of galaxies, a scientist, fluent in the language of light years and equations. But to those who followed his journey, Avi Loeb is something else entirely, a dissenter who believes that curiosity is sacred and that science without imagination is only bookkeeping. He was born on a small farm in Israel where the night sky was not a concept but a companion. As a boy, he spent more time looking upward than ahead, fascinated not by stars themselves but by the spaces between them. His early work was in plasma physics and black holes. He could have lived a perfectly distinguished life as a theoretical astrophysicist, respected, cited, forgotten only by death. But Loeb's mind was never comfortable staying inside equations. He wanted to ask questions that made institutions uneasy. The instinct first made headlines in 2018 after the discovery of Oumuamua, the cigar-shaped object that sliced through the solar system at impossible speed, tumbling like no asteroid or comet ever observed. Most astronomers dismissed it as a fragment of rock or ice. Loeb, after months of analysis, published a paper suggesting a far more unsettling possibility that Oumuamua might be artificial, perhaps a piece of light sail technology propelled not by fuel but by sunlight itself. He didn't say alien spaceship. He didn't claim to know what it was. He simply followed the data. The object's brightness changed oddly. It accelerated slightly without visible outgassing. It was flatter than any natural rock should be. His conclusion was not faith, it was logic extended past habit. But academia doesn't reward heresy, even the logical kind. Colleagues rolled their eyes. Some called it a publicity stunt. Others accused him of science fiction disguised as research. He received invitations to fewer conferences, saw committees quietly distance themselves. Stick to theory, one colleague warned him at a meeting. Leave the aliens to Hollywood. He smiled, as he always does when confronted by caution, and replied softly, "If nature presents a riddle, we must not be afraid of the answer." The backlash didn't silence him, it refined him. In the years that followed, Loeb established the Galileo Project, a privately funded initiative to search for technological relics of extraterrestrial civilizations using open empirical methods. His aim was simple: to bring the study of anomalous interstellar objects into the scientific mainstream, to treat the extraordinary with the same discipline as the ordinary. If we have instruments that can detect distant exoplanets, he argued, why not use them to detect artifacts? He wasn't chasing science fiction. He was chasing evidence and defending the right to look. So when 3i Atlas appeared with its impossible chemistry and backward jet, the world turned once more to the man they had once mocked. And Loeb, true to form, refused to retreat. He analysed the Keck spectra line by line, comparing it with known industrial compounds. He reviewed orbital data, searching for deviations that might suggest propulsion. His first interviews were cautious, even self-effacing. There could be natural explanations, he repeated. But if the evidence persists, we should consider others. Yet what struck those who listened wasn't his theory, it was his tone. Calm, patient, almost pastoral. He never spoke of aliens. He spoke of curiosity, of humility before the unknown. The universe is under no obligation to conform to our expectations, he said. If we wish to be truly scientific, we must listen when it surprises us. Perhaps that was what unsettled his peers most. Not the possibility of life, but the reminder of uncertainty. For decades, modern astrophysics has lived in the comfort of order, dark matter, dark energy, exoplanets, black holes, vast mysteries, yes, but contained within equations. Loeb's work cracked that comfort. He reminded the scientific world that discovery is not a safe profession. When journalists pressed him on the criticism, he responded with the kind of answer that sounds like resignation but is really faith. I follow the evidence. If it leads nowhere, I learn. If it leads somewhere, I follow farther. Either way, the truth will still be there waiting. He knew what it cost to say such things in public. Grants vanish. Invitations stop. But he also knew something deeper, that the cost of silence is greater. And so while governments withheld data and algorithms erased voices, Avi Loeb kept speaking. He wrote op-eds, gave interviews, even hosted open seminars, where he invited young scientists to analyze the 3I Atlas findings themselves. He told them to question everything, especially him. Doubt, he said, is the oxygen of science. It was not defiance. It was devotion to the discipline he loved, to the idea that skepticism is not the absence of belief, but the courage to believe nothing until tested. To his students, he became less a professor and more a kind of pilgrim, walking the thin line between reason and wonder, between the known and the possible. In that quiet resolve, Loeb embodied a truth older than any telescope, that science is not a fortress built of certainty, but a lantern carried into mystery. And while the world's institutions turned their eyes away from 3I Atlas, Avi Loeb kept his fixed upon it, not as a believer, but as a listener. Because somewhere between the silence of the agencies and the noise of the internet, he still heard something else, faint, mathematical, insistent, the sound of the universe asking a question only the brave still dared to answer. By mid-October 2025, the debate over 3I Atlas had narrowed to a single question: how many coincidences equal intent? Even the most cautious scientists admitted that the data refused to behave. Avi Loeb called them persistent anomalies, 7 deviations so statistically unlikely that taken together they painted a pattern impossible to ignore. He didn't frame them as proof, he called them breadcrumbs. But each breadcrumb led farther from the comfort of natural explanation. 1. The trajectory anomaly. 3I Atlas did not wander into our solar system at random. Most interstellar objects arrive from arbitrary directions, slicing through the planetary plane at steep angles like pebbles skipping across water. This one entered almost perfectly aligned with the ecliptic, the thin plane in which Earth and the other planets orbit the Sun, just 489 degrees off. To grasp the odds, imagine dropping a coin from an airplane and having it land edge first on a line painted down a runway. That's how improbable this alignment is. Less than 1% of possible arrival angles. Natural maybe, but the path looks chosen. 2. The chemical impossibility, nickel without iron. In stellar forges, these two elements are inseparable twins, born together, dying together, cooling together in the dust that becomes comets. Finding nickel without iron is like finding smoke without fire. Yet the Keck spectrograph recorded streams of nickel tetracarbonyl, a molecule so specific that on Earth it exists only in refineries and metallurgical plants. It is not chemistry, it is industry. 3. The thermal contradiction. Infrared data showed the object releasing gas as though heated by sunlight, yet its surface remained inexplicably cold. Imagine watching a person sweat profusely inside a freezer. A comet that outgasses must absorb heat. This one radiated almost none. Something was venting material without getting warm, as if the process were regulated, not reactive. 4. The sunward jet. All comets exhale away from the sun. Radiation pressure and solar wind push their tails outward like smoke blown from a candle. But 3I Atlas was inhaling a plume directed toward the sun, steady and narrow as though a thruster were firing against the current. A violation of one of astronomy's simplest classroom laws. Loeb's understated verdict: this looks controlled. 5. The mass paradox. Tracking data showed 0 measurable acceleration from that outgassing. For a comet venting so much material, some change in motion should have been obvious. The absence of movement implies extraordinary mass, billions of tons of density, compacted into something only a few kilometers wide. If it were natural ice and dust, it should drift like a balloon. Instead, it moved like a planet. 6. The wow signal alignment. When astronomers traced the object's path backward through time, its origin region brushed within 9 degrees of the famous wow radio signal, detected in 1977, that unexplained 72-second burst from the direction of Sagittarius. 9 degrees in cosmic terms is the width of your thumb held at arm's length against the Milky Way. Coincidence? Probably. But probabilities stack, and with each alignment the universe seemed to whisper, look closer. 7. The observation window. Its perihelion, closest pass to the sun, occurs while hidden behind the sun from Earth's view. At the precise moment when its behavior could reveal its nature, the entire planet is blinded by solar glare. It is the cosmic equivalent of a magician turning off the lights during his most important trick. To Loeb, that timing felt suspiciously optimized. Individually, each anomaly could be explained away with enough imagination, a rare trajectory, exotic chemistry, misread spectra, unusual spin-faulty sensors, but together they formed a symmetry that data alone could not dismiss. Scientists live by pattern recognition. It is how chaos becomes law, how random numbers arrange into orbits and noise crystallizes into knowledge. But pattern recognition has a shadow, the temptation to see design, where there is only chance. Every discovery walks that edge. Loeb knew it. He'd said it many times. We must be skeptical of miracles, but also skeptical of coincidence. Because somewhere between the two lies the truth, the narrow space where evidence stops being noise and begins to sing. And as the anomalies multiplied, that song grew louder, until even the most cautious minds could hear the faint rhythm beneath the data. Not proof, just pattern. But pattern is where meaning begins, the images that change the conversation. At first it was just data. Columns of numbers, photon counts, wavelength intensities, emission profiles. To most readers of the Keck Observatory release, they looked like the usual language of the stars, cold, dense, impenetrable. But buried inside that data set was something so strange that even the algorithms hesitated before flagging it as shape-repeating persistent. It began with an anonymous post from a Reddit user who called himself Astropixel Hunter. He had downloaded the raw spectroscopic cubes from Keck's public archive, the same files that measured 3I Atlas's impossible nickel tetracarbonyl emissions. He wasn't a professional astronomer, just a software engineer with a decent telescope and a love for open-source science. What he did was simple. He mapped the concentration of nickel emissions in 3 dimensions, then flattened them into a spatial overlay across visible light imagery. What appeared on his screen stopped him cold. The emission wasn't uniform as comets normally are. It was structured. 3 bright nodes of nickel radiation, equidistant from one another, forming what looked like an equilateral triangle, connected by faint filaments of lesser intensity, like beams of energy suspended in vacuum. At the center sat a 4th concentration point, circular radial lines extending outward like the spokes of a wheel. He posted the image cautiously captioned, "Probably processing error, but does anyone else see this?" Within hours, the thread exploded. Other amateurs downloaded the same data. A French astrophotographer ran it through MaximDL, subtracting noise and applying multiband filters. An engineer in Chile used Python scripts from a planetary science GitHub repository to reconstruct the spectral map independently. A graduate student in Toronto cross-checked it with archived frames from the Subaru telescope, different instruments, same geometry. 3 points each 2 kilometers apart. Perfect symmetry, not noise, not compression artifact. Something real, something deliberate. They began to call it the triangle in the dark. For a brief electric week, astronomy felt like detective work again, strangers collaborating across continents, united not by credentials but by wonder. They weren't proving anything, they were simply refusing to look away. And for the first time the story felt cinematic. People overlaid the pattern onto simulated comet models, watching as the triangle rotated in slow motion against the black of space. Animations spread across social media, 3 glowing nodes pulsing in rhythm like the corners of a machine waking up. The geometry wasn't just visible, it was beautiful. Professional astronomers reacted carefully, as they always do. Some suggested crystallization effects within the comet's metallic dust-nickel vapor, freezing into polygonal lattices. Others proposed rotational outgassing, as the nucleus spun jets might vent preferentially along 3 fixed axes. Possible, yes. But no one could explain why those axes formed a perfect triangle, or why the pattern persisted across multiple observation sessions weeks apart. And when independent analysts aligned the nickel map with the optical coma images, they noticed something more: faint radial symmetry, extending from the central node like circuitry embedded in cloud. The more they cleaned the data, the more intentional it looked. KEK's official press release never mentioned the geometry. But privately, several team members admitted they'd seen it. "We thought it was an artifact," one said later under anonymity. But it was there in every wavelength: infrared, ultraviolet, even radio. The shape didn't dissolve when you changed filters. For Loeb, it was the moment the conversation shifted. He ran the data through his own analytical pipeline testing for statistical coincidence. The odds that 3 nickel peaks would align in a perfect equilateral formation by chance were less than 1 in 100,000. In his notebook, he drew the triangle, wrote a single word beneath it engineered. In a later interview, his tone was gentle but unflinching. The spatial distribution of nickel emission is inconsistent with random outgassing. This looks controlled. This looks engineered. The media clipped that sentence and made it sound sensational. But what most people missed was the line that came after the one that defined the stakes. If this geometry holds through perihelion, if it survives the sun's heat, then it's not ice. A natural comet approaching that close to the sun should fracture and lose all structure. A machine, on the other hand, would maintain it. As October deepened, the idea of geometry in the dark spread beyond science circles. Artists painted the triangle in glowing silver on black canvases. Musicians sampled Loeb's voice into ambient tracks. Someone 3D printed the pattern and placed it on their desk like a relic from the future. And yet, beneath the fascination ran a quiet unease. Humans have always used geometry to recognize intelligence, from the pyramids to the golden ratio, from crop circles to computer code. A triangle means design, intent, purpose. But here was a triangle not carved in stone or drawn on Earth, but floating between stars. A shape older than us, written in nickel light, turning slowly toward the sun. And if it was real, if it remained when 3I Atlas emerged from its fiery passage, then it would no longer be a comet at all. It would be the first architecture we've ever seen in space. The Martian Enigma. On the night of October 4th, 2025, a sliver of the Martian sky captured humanity's breath again. From Jezero Crater, the Perseverance rover, that patient, dust-covered survivor of countless Martian storms, took a series of routine navigation camera images. They were never meant for astronomy. The navcams were built to scan terrain, not the heavens. But one of those frames contained something so out of place that for a few hours before the silence descended, even NASA's internal servers hummed with disbelief. Across the sky stretched a streak thin, elongated 4 times longer than it was wide. Too sharp to be motion blur, too defined to be cosmic ray noise. At first glance, it looked like a wound of light slashed across the night. The file's metadata placed the exposure at 22:17 local time, roughly when 3I Atlas was predicted to be passing overhead from Perseverance's vantage point. But that wasn't what drew attention. What drew attention was the math. When astrophysicists calculated the apparent size of the streak given the camera's focal length and the estimated distance to 3I Atlas, they found something absurd. If it truly represented the comet, the visible object would span 50,000 kilometers wider than Earth itself. That couldn't be right. Nothing natural could appear that large at that range. So the debate began. NASA technicians offered the simplest explanation first: a long exposure. The rover's cameras often take multiple frames with exposure times up to several minutes to balance light conditions. If the shutter remained open while 3I Atlas crossed the field of view, the moving object would appear as a bright streak tracing its path across the stars. Case closed. Except as Avi Loeb and independent analysts pointed out that reasoning only worked if the exposure lasted over 10 minutes. And Perseverance's night sky calibration sequences rarely exceed 3 seconds. If the frame was single exposure, as some leaked telemetry suggested, then the light wasn't movement. It was something glowing in place, radiating across multiple pixels simultaneously. That single contradiction split the community in half. To understand how these arguments evolve, you have to understand how Mars imaging works. Perseverance carries multiple cameras: the Mastcam Z for high-resolution panoramas, the Navcams for driving Hazcams for obstacle detection, and specialized instruments like Supercam for laser spectroscopy. None of them were designed for astrophotography. Their optics are unfiltered for faint starlight, optimized for the dusty red brightness of daylight on Mars. Long exposures risk image noise, pixel saturation, and ghosting. When the team captures the night sky, they usually stack dozens of short frames to simulate brightness without blurring, so a clean continuous streak across a single frame shouldn't exist. It violates operational logic. Naturally, memories of the face on Mars resurfaced. In 1976, NASA's Viking 1 orbiter photographed a mesa in the Cydonia region that under a particular angle of sunlight resembled a human face. Newspapers screamed evidence of alien civilization. Decades later, higher resolution images revealed nothing more than a trick of light and shadow, a geological illusion. The lesson of Cydonia has become doctrine in planetary science. Extraordinary images demand ordinary explanations first. So many assumed the streak must be another Cydonia, a sensor artifact, a dust glint, a cosmic ray hit, something banal made to look profound by distance and hope. But that assumption stumbled over one quiet fact. The rover wasn't supposed to be looking up. Its mission plan for that Sol-listed ground operation, soil sampling, navigation testing, and environmental data gathering. The camera mast should have been pointed downward, not at the sky. No official documentation explains why it pivoted. If the observation was automated, triggered by software, then the rover's AI must have detected a sudden increase in brightness overhead, something worth logging. If it was commanded from Earth, then someone, an operator, an engineer, a flight planner had instructed Perseverance to look up. And if that command came, it would have been sent hours earlier, precisely timed for 3 Atlas's closest approach to Mars. A small circle of mission analysts began whispering about it. One called it the Jezero glance. Another described it as a photograph that shouldn't exist, taken by a camera that wasn't supposed to be watching. Officially, NASA maintained silence. The agency's public affairs office cited the ongoing government shutdown as the reason no image metadata could be released. No exposure time, no stacked frame count, no confirmation of whether the shot was deliberate. But the silence itself spoke volumes. Because whether the streak was a comet trail, a glitch, or something closer, something within Mars's orbit, the question remained: why was Perseverance looking upward that night at all? Rovers don't gaze. They execute commands, and in the still air of Jezero crater under a thin Martian sky, a machine built to study rocks may have witnessed the beginning of a story no one was ready to tell. The perihelion blackout. October 29th, 2025. For 12 days the universe drew its curtain. From Earth's perspective, 3I Atlas passed directly behind the Sun, a region astronomers call solar conjunction, the place where observation ends and speculation begins. During that period, no telescope on or near Earth could see it. The Sun's glare overwhelmed every instrument. Even the best spaceborne observatories, SOHO, Stereo Solar Orbiter, were blinded by the same brilliance that sustains life itself. It is a celestial irony older than humanity. The moment of greatest importance is always the one we cannot watch. In the language of orbital mechanics, perihelion is simple, the point of closest approach to the Sun where gravitational pull is strongest and velocity peaks. For comets, it's the crucible, the trial by fire, that determines survival. Most crumble there. Ice vaporizes, rock fractures, tails bloom into luminous ghosts. If a comet endures perihelion intact, it tells us something about its composition, how tightly its matter clings to itself, how real its structure is. But for 3I Atlas, perihelion meant more than survival. It was the critical window, the moment when a controlled trajectory, if such control existed, could change course most efficiently. In orbital dynamics, a small push at perihelion can alter an interstellar path by millions of kilometers. It is the universe's perfect turning point. Loeb called it the clandestine window, because in that blinding alignment, anything could happen unseen. To visualize what occurred, imagine standing in a dark theater as the lights dim. The curtain closes. You hear only motion behind it. Footsteps, the shifting of scenery, the quiet preparations for something you're not yet meant to see. That was late October 2025, the cosmos itself rearranging its stage behind a curtain of fusion. During those days, ground-based observatories fell quiet. The Solar Dynamics Observatory reported elevated interference from the Sun's corona. Communications with several Mars orbiters suffered temporary signal degradation. It was expected, routine, unremarkable. Yet to those who had followed the story, the scientists, the amateurs, the insomniacs tracing every fragment of data, it felt like a blackout written into the script. Astronomers tracked the object's predicted course through simulation alone. Its velocity was estimated at 68 kilometers per second. Its perihelion distance, roughly 0.47 astronomical units, inside Mercury's orbit, close enough to feel the Sun's magnetic breath. At that proximity, any normal comet would flare brilliantly, its volatile elements erupting into a visible halo. But in the final pre-blackout images, 3I Atlas's brightness curve remained stubbornly flat. No surge, no tail, no thermal bloom. It slipped behind the Sun like a submarine diving beneath the horizon, silent, intact, deliberate. The blackout lasted 12 Earth days, 12 days of nothingness. For radio telescopes, it was literal silence. The sun's plasma drowned out all frequencies from the object's direction. For optical instruments, it was blindness so pure it felt almost religious light itself forbidding sight. And in that blindness, imagination rushed to fill the void. Podcasts speculated about course correction burns. Amateur astronomers proposed that the object might use solar gravity as a slingshot changing direction toward the outer planets, or away from the ecliptic entirely. Conspiracy boards whispered about intelligent perihelion maneuvers. Loeb stayed measured. If the geometry remains consistent before and after perihelion, he told a student interviewer, we will know it was inert. But if the orbit shifts, then something acted. He compared the event to an eclipse of truth. Every civilization hides its workings in brightness, he wrote later. Even the universe does. During the blackout, astrophysicists met daily via encrypted channels, comparing predictive models like gamblers whispering bets. The shape of the post-perihelion path became a kind of scientific prayer, would the object re-emerge where gravity demanded or somewhere new. Meanwhile, solar scientists quietly noted something peculiar. A minor coronal mass ejection recorded on October 30th had an unexpected vector angled not outward, but slightly upward toward the very coordinates where 3I Atlas was believed to be. It was probably coincidence. The sun erupts constantly. But when the ejection's data was layered over the object's last known path, the overlap was exact. It was as though the sun itself had answered with movement. And so for 12 days, the human species did what it does best when faced with mystery. It waited. The telescopes cooled in their domes. The news cycle wandered elsewhere. Only a few stubborn watchers kept refreshing telemetry feeds, hoping for a flicker of return. In that silence, the tone of the story changed. It no longer felt like a scientific observation, but a pilgrimage of patience. The thing we sought had stepped behind the blinding light, leaving us to contemplate absence itself. Because that's what science is at its heart, faith in the return of data. Belief that when the curtain lifts again, what reappears will still make sense. But sometimes, as Loeb quietly reminded his colleagues, the curtain doesn't reveal the same scene. Sometimes the stage is empty. Sometimes something new walks in. October 29th became that moment, the deep inhale before revelation. The cosmos holding its breath. A blackout written not by censorship, but by geometry. The stage lights dimmed. The audience waited. And somewhere behind the sun, the object that shouldn't exist moved unseen, deciding what story it would tell next. The leak that knew too much. It began as many 21st century mysteries do, in a place no one takes seriously until it's too late. At 03:27 UTC, on October 31st, 2025, an anonymous user on ORNT, the paranormal board of 4chan, posted a message titled, simply, when it comes back, check for rotation drift at 0.09 gigahertz HR. It's not a comet, it's a cue ball. Beneath the post was a string of coordinates, a rough orbital sketch, and a single line that would in retrospect ignite a minor digital firestorm. Nickel lines with a giveaway. Don't look for tail structure, look for field harmonics. The thread went largely unnoticed at first, buried under the usual clutter of cryptic prophecies and conspiratorial ramblings. But 2 days later, when preliminary tracking data leaked from an ESA server showed 3I Atlas emerging from behind the sun with a measurable spin change of 1 durin per hour, the post resurfaced like a ghost that had known the future. The word that drew everyone's attention was cue ball, a term most readers had never heard, but one that sent a shiver through the scientific community. In theoretical physics, a cue ball, short for quantum ball, is a hypothetical form of stable, self-contained matter predicted by certain supersymmetric field theories. Imagine a droplet of pure field energy not built from atoms, but from the oscillations of a quantum field itself. It would be dense, smooth, and electrically neutral. In some models, cue balls could be dark matter candidates, invisible most of the time, but capable of interacting through unusual electromagnetic signatures. They are neither alive nor mechanical, more like cosmic solitons, stable knots in the fabric of space-time. In other words, the universe's way of tying a bow in its own equations. To physicists, cue balls are beautiful because they unite opposites. They are both particle and object, both microscopic and celestial. Theoretically, one could drift through space for billions of years untouched by decay, glowing faintly where its field interacts with ordinary matter. The 4chan post claimed 3I Atlas wasn't engineered at all. It was natural, but from a layer of nature we hadn't yet seen. It's not alien technology, the poster wrote. It's physics doing something we never asked it to do. Skeptics pointed out the obvious 4chan is a swamp of coincidence. A million predictions bloom there daily. One is bound to fit the news. Still, the precision of the numbers, the angular drift, the reference to nickel emission lines, the suggestion to watch for field harmonics made scientists pause. Within a week, discussion threads appeared across Reddit's astronomy and ask. Science half mockery, half fascination. Astrophysicists who had never visited those forums found themselves explaining the math of scalar fields to bewildered hobbyists. Somewhere between chaos and curiosity, the leak took on a strange life of its own. A few graduate students tried to model how a cue ball might mimic a comet. They found that if such an object carried an oscillating electromagnetic field, it could indeed ionize nearby metal atoms, explaining the anomalous nickel without iron. Others noted that a cue ball passing close to the sun might produce a sunward jet not from propulsion, but from magnetic interaction, a self-consistent but still wildly speculative scenario. Was it possible that the anonymous poster simply knew their physics too well, or had insider access to restricted orbital data? No one could prove either. The post vanished within 48 hours, deleted by the author or by the site's moderators. What remained were screenshots and speculation. Internet sleuths tried to trace the IP address, claiming it originated from an academic network in Switzerland. CERN denied any involvement. Avi Loeb asked about the incident during a livestream, smiled faintly. I read it, he admitted. It's interesting fiction, but we should remember that good fiction sometimes precedes science. Jules Verne imagined submarines before we built them. He went on to explain cue ball theory to the audience in plain language, careful to bridge wonder with discipline. A cue ball, if it exists, would be a fragment of the universe that decided to stop expanding, a kind of frozen vibration. It would appear artificial because symmetry always looks designed to us. But nature too loves symmetry. Then, almost as an afterthought, he added, if someone out there predicted its rotation correctly, perhaps they simply listened to the data sooner than we did. The cue ball hypothesis didn't last long in mainstream discussion. Within a week, peer reviewers dismissed it as numerology and coincidence. Yet something about it lingered, not as belief, but as metaphor. Because whether 3i Atlas was a machine, a mineral, or a mathematical knot, the idea of the cue ball captured the spirit of the mystery, an object that doesn't decay, doesn't belong, yet refuses to disappear. In that sense, the anonymous poster achieved what all scientists secretly seek, not certainty, but the moment before it when the universe tilts slightly toward revelation. Loeb would later call that post a mirror of our times, half noise, half insight. And perhaps that's what the 4chan message truly was, an echo from the future, or simply another coincidence in a cosmos already fluent in both. The building, hypothesis. By mid-November 2025, whispers had turned into coordinates. The first came from an observatory in southern Chile, faint intermittent light sources recorded in the same sector of space where 3i Atlas had vanished behind the sun weeks earlier. The points didn't behave like stars, they drifted. Slowly, consistently. Each movement subtle, less than a kilometre per second, but steady enough to trace. A week later, an amateur radio astronomer in Canberra noticed something similar bursts of narrowband emission near 1420 MHz, the hydrogen line precisely the frequency used in radio astronomy to listen for cosmic communication. The signals weren't strong. They were rhythmic, repeating every 78 minutes, the same period as later noted by independent skywatchers as a low Mars orbit. When NASA's Mars Reconnaissance Orbiter resumed normal operations after conjunction, its imaging schedule curiously avoided that region. The official reason, thermal calibration. But enthusiasts comparing data noticed a black void in the usual feed, a narrow strip of missing sky between Jezero Crater and the Southern Highlands, right where the mysterious drift lights had been seen. The idea that began to form among independent researchers was equal parts science and story. What if the object hadn't left Mars orbit? What if it had left something behind? At first glance, it sounded absurd. Interstellar objects don't build. They fall, they melt, they move on. But the data didn't fit the normal. It never had. One European Space Agency analyst speaking off record called it the construction hypothesis. Others preferred subsidiary activity. Loeb himself, ever cautious, referred to it only as local persistence. For the public, the idea found shape through imagination. artists rendered images of strange triangular satellites glimmering in Mars's dusk, thin frames like scaffolding gliding across red cloud. The tabloids dubbed them Atlas fragments. Yet for scientists, the analogy was more grounded and uncomfortably familiar. When Earth launched its first satellites in the late 1950s, ground observers didn't know what they were seeing. The Soviet Sputnik blinked across the night sky, and professional astronomers initially logged it as a moving star. Even the Echo communications balloons of the early 1960s were mistaken for natural phenomena, bright specks drifting against the constellations. Only after days of triangulation did the truth emerge humanity had put architecture in orbit. Now 70 years later, the pattern felt inverted. An architecture not ours might be rising unseen above another world, and once again our instruments were too slow to recognize it. What the Chilean observatories captured next deepened the unease. When the lights were tracked over several nights, they revealed consistent geometric spacing 3 points, forming a loose isosceles configuration, each maintaining relative distance within a margin of meters. That kind of stability implies coordination, either physical connection or active station keeping. Neither made sense for debris or rocks. The symmetry was too clean. As the data accumulated, analysts began referring to the phenomenon in shorthand the triangle at Mars. Avi Loeb, contacted for comment, was characteristically restrained. If 3 Atlas were engineered, he said during an interview for Scientific American, it would make sense for it to leave something in orbit for observation. A subsidiary probe or deployment array would be the logical step. But logic is not evidence. He smiled, slightly aware that every word he spoke would be dissected. Still, he added, if we had built such a device ourselves, we would do exactly that: distribute modules around the host planet, synchronize their motion and wait. Waiting is efficient. And so quietly, a new hypothesis took form: not the alien visitor, but the alien engineer, not a comet, but a constructor. Something that did not arrive whole, but in pieces assembling under cover of the Martian sky, beyond the reach of our telescopes, behind a planet we thought we understood. The image was at once terrifying and serene, invisible frames orbiting in silence, slowly building something we could not yet name. Scientists called for restraint. No conclusive evidence, the official statements repeated. Yet in internal notes leaked from the European Southern Observatory, a single line stood out: geometric correlation consistent with active pattern maintenance. It didn't say machine, it didn't say life, it said maintenance, and maintenance implies purpose. By the end of November, Loeb's own notes from the Galileo project contained one understated observation circled in pencil, later quoted endlessly online. If geometry persists, then structure is intended. If structure is intended, then subsidiary deployment would be logical. That single word, logical, carried more weight than any declaration could. Because beneath its academic calm was the most human of realizations that logic itself might not belong solely to us anymore. Somewhere above Mars, an unseen architecture could be forming quiet, deliberate mathematical, not as invasion or miracle, but as the next stage in a pattern the universe had already begun to draw. And once again, as always, humanity stood below, staring up at the red planet, wondering if the lights were just stars. The November revelation. By the final days of November 2025, the world stood in a strange collective stillness, a pause between knowledge and belief. Somewhere beyond Mars, the Third Atlas was about to emerge from the sun's shadow for the first time since its blinding perihelion passage. And every telescope capable of tracking motion through the solar glare from Pan stars in Hawaii to Gaia James Webb and China's fast radio dish was watching the same empty coordinates. What would reappear there would decide everything. The prediction windows varied by only minutes. If 3i Atlas was natural, it should come out of conjunction in the same orbital path predicted by celestial mechanics. Trailing dust perhaps fractured its mass, diffused by solar heat. It would drift outward like every other comet in recorded history, another shard of cosmic debris on its way to nowhere. If, however, it emerged intact or worse on a new trajectory, then the debate that had simmered across universities' newsrooms and data servers for a year would ignite overnight. Trajectory or fragmentation, chance or control, those were the only 2 doors left. Inside observatories, the atmosphere was less of anticipation than reverence, the kind of hush one finds in cathedrals before the first note of music. Graduate students whispered in corridors, radio operators leaned toward their screens as if the static might speak. In the control room at Keck, one scientist compared the night to the second half of a coin flip we've been waiting months to land. Around the world, teams calibrated sensors, cleaned mirrors, rechecked timestamps. Every few hours, clouds of rumour drifted across encrypted group chats, claims of early detection quickly denied. Then came the economic ripples. Futures markets in aerospace and energy spiked unpredictably. A single rumour that NASA had requested emergency satellite repositioning sent communication stocks into brief freefall. The European Space Agency's insurance partners quietly froze underwriting on several missions pending orbital analysis. In New York, hedge funds began buying long positions in precious metals, hedging for the unknown, as one analyst dryly put it. Because markets like people understand uncertainty as danger, and Thriss Atlas had become uncertainty incarnate, governments prepared statements no one wanted to release. The United Nations Office for Outer Space Affairs drafted language about non-hostile anomalous phenomena. The US State Department circulated a confidential memo titled Global Communication Coordination in Event of Confirmed Artificial Object. Even the Vatican Observatory scheduled a closed symposium on theological implications of extraterrestrial intelligibility. Most of these precautions would never see daylight, but their existence betrayed what the data had already done. It had forced civilization to contemplate what it means to no longer be alone, even if the object proved nothing more than metal and trajectory. In Harvard's astrophysics building, Avi Loeb worked quietly at his desk, reviewing the orbital projections one final time. His conclusion was as measured as it was momentous. If its course shifts by even half a degree, he said, we will have witnessed the first deliberate maneuver by an interstellar object. He paused, the faintest smile flickering. And if it breaks apart, then nature will have given us a beautiful accident. Either outcome teaches us something profound. That, perhaps, was what most people missed, that discovery isn't about winning the argument, but listening to whatever the universe finally says. The night before the expected reappearance, a kind of vigil unfolded across the planet. Not the dramatic kind, no crowds, no countdowns, but a quieter communion. Scientists staying awake in their labs, hobbyists setting up telescopes on rooftops, anonymous watchers refreshing tracking feeds through half-closed eyes. A digital hush wrapped the world like the collective breath held before dawn. Even the usual noise of online speculation slowed. Threads on Reddit went still. Live streams looped empty starfields. In that silence, humanity rediscovered something it had nearly forgotten: humility. At 04:17 UTC, the first preliminary feed from the Gaia probe was expected to resolve the region where the object should emerge. At 04:16, every instrument was blind. At 04:18, the raw telemetry began arriving, faint jittering, incomplete. Somewhere in those pixels lay the answer was 3i Atlas, disintegrating into the ordinary dust of a comet. Or had it changed direction, a new vector, a new intent, a whisper of motion that should not be, no one knew yet. For a few hours more, the universe kept its secret. And in that suspended breath between signal and silence, fear and wonder, humanity found itself exactly where science lives, waiting for the light to return. These silence between agencies. In early December 2025, the world waited for clarity and received coordination instead. The much-anticipated post-perihelion data from 3i Atlas should have been a triumph of international science, a rare moment of collaboration across continents and rival space programs. Instead, it became a study in restraint. On December 2nd, NASA's Jet Propulsion Laboratory quietly postponed its planned briefing, citing incomplete verification of orbital parameters. The European Space Agency postponed theirs the next morning for data reconciliation. China's CNSA issued no update at all, and the UAE's HOPE mission, once again the most transparent of the group, published only a single image of Mars's limb with the telling caption, "No visible anomaly detected." 4 agencies, 4 silences. Different languages, same sentence. To the public, it looked like conspiracy. To those who work inside the machinery of space programs, it looked like bureaucracy, an almost choreographed pause. Every agency has protocols for anomaly management. Before any new data goes public, it must pass through internal review committees, mission leads, communications officers, cross-agency liaisons, and increasingly legal consultants. These committees exist not to conceal truth, but to protect credibility, to prevent another premature headline that collapses under scrutiny. But when anomalies grow large enough to threaten the boundaries of known science, those same safeguards become walls. There is precedent. When the Chelyabinsk meteor exploded over Russia in 2013, it took nearly 5 hours for the first verified reports to reach Western media, even though hundreds of videos were already online. The delay wasn't denial, it was disbelief. Agencies had to confirm what eyewitnesses already knew, and when Oumuamua crossed the inner solar system in 2017, the delay between its detection and its official recognition as interstellar wasn't a cover-up, it was hesitation. Scientists had never before named something from beyond our system. Naming it meant admitting that interstellar visitor was no longer poetic metaphor but data. That same reflects the need to translate shock into paperwork now governed 3 Atlas. Still, the timing of the 2025 blackout felt too perfect to ignore. Analysts noticed that all 4 agencies' communication departments entered information lockdown within a 3-hour window. The language of their press releases matched almost word for word further analysis required before publication. This kind of synchronization doesn't happen by coincidence, it happens by coordination. Behind the scenes, the Committee on Space Research COSPAR serves as a quiet diplomatic bridge between agencies mediating international science policy. In moments of potential global significance, asteroid impact risk, planetary contamination, unverified discovery, COSPAR can invoke an informal pause protocol, allowing time for collective verification before any single country releases findings. That protocol had been invoked only 3 times in history, once during the Apollo 11 quarantine, once after the ALH 84001 Mars meteorite announcement, and once briefly during Oumuamua's initial orbital reclassification. If insider leaks are accurate, 3I Atlas became the 4th. This coordination was not suppression in the cinematic sense, no secret cabal, no erased files. It was something subtler, protective secrecy born of institutional self-preservation. Space agencies exist at the fragile intersection of science and politics. Their budgets depend on public confidence, their missions on international partnerships. A single, mistaken statement, one premature word like artificial, could unravel decades of trust. So they held their tongues, not because they didn't know, but because they didn't yet agree on what knowing meant. Sociologists of science have long argued that every era of discovery tests the boundary between transparency and stewardship. When information could change the course of belief itself, institutions revert to the most ancient impulse, guard the threshold. To many outside the system, this feels like betrayal. But to those within it, it feels like responsibility to protect the fragile bridge between data and meaning until it's safe to cross. Avi Loeb understood this tension intimately. In an interview with The Atlantic during the blackout, he said, "Science belongs to everyone, but its guardians fear chaos more than error. They want truth, yes, but truth that doesn't burn." His words captured the paradox at the heart of the moment. Trust demands openness, survival demands silence. And somewhere between those 2 necessities, the institutions that speak for humanity's curiosity found themselves unable to speak at all. The irony was not lost on anyone. The search for other minds had revealed first the limits of our own cooperation. While telescopes stared upward into darkness, governments stared sideways at one another, waiting to see who would blink first. The silence between agencies became more eloquent than any press release, a quiet truce at the edge of revelation, a collective holding of breath before the next transmission. The retrograde problem. When the orbital data finally stabilized in December 2025, it revealed a single number that made astronomers stare at their screens in disbelief. Inclination, 178.4 Den. That meant one thing: retrograde motion. 3I Atlas wasn't simply visiting our solar system, it was moving against it. In celestial mechanics, almost everything flows the same way. The planets, asteroids and comets orbit the Sun in one shared current, the slow, clockwise tide of ancient angular momentum inherited from the disk of gas that birthed them. Even most interstellar interlopers like Oumuamua and Borisov had trajectories that loosely aligned with that flow. But a retrograde object is a rebel in that river. It doesn't swim with the current, it fights upstream. To visualize it, picture a vast cosmic whirlpool 1 billion kilometers wide, spinning one way since the dawn of time. Every planet, moon and rock circles in that agreed-upon direction, a dance older than life. Then from the dark beyond, something slips into the spiral backward like a salmon leaping against a flood. That's what 3I Atlas was doing. Its path sliced through the inner solar system head-on, a counterclockwise intruder, colliding with the clockwise momentum of everything else. The implications were staggering. For mission planners, retrograde motion is a nightmare. Intercept missions depend on orbital harmony. You launch a probe to meet your target by matching its motion, riding the same river of gravity until rendezvous becomes possible. But meeting something moving the other way means fighting the entire flow of the solar system. Even with nuclear propulsion, an intercept vehicle would need DV change in velocity far beyond current capability. Matching speed with 3i Atlas would be like trying to catch a bullet by throwing another bullet from the opposite direction. NASA engineers quietly running simulations realized the absurdity. Even a fast-track trajectory from Earth's L1 point would arrive years too late. One internal memo leaked to journalists simply read "no feasible intercept, object uncatchable." But the physics raised a deeper question. How did it end up retrograde at all? Natural interstellar visitor could approach from any random direction. Yes, but to a line so precisely against the ecliptic's flow, slicing almost perfectly through the solar plane required precision bordering on intent. Random capture by gravity could explain an angle, a tilt, even a curve. But opposition, a 180-degree reversal, was statistically microscopic. Avi Loeb, cautious as ever, put it in elegant understatement. If 3i Atlas's orbit was accidental, it was the most disciplined accident the cosmos has ever produced. The retrograde problem, as it came to be called, divided theorists. Some proposed that the object had passed near a massive body, a rogue planet or a dense brown dwarf that slingshotted it into a reverse trajectory before it reached us. Others invoked the chaotic dynamics of galactic tides, suggesting it had wandered for eons, tossed by invisible gravitational storms. But the simplest alternative, the one that haunted everyone, was design. Because if one wanted to study a solar system discretely approaching against its orbital flow makes sense. Every natural body moves one way, sensors and radars are calibrated for that rhythm. A retrograde course becomes the perfect blind spot coming from the direction few systems bother to look. It is stealth by physics. Within weeks, astrophysicists began describing the orbit in poetic terms. One likened it to a river where one fish swims upstream while all others drift down. Another compared it to a clock with one hand running backward, marking not time, but intention. The language of mechanics had become metaphysical. Retrograde motion was no longer just a direction, it was an attitude. And so the question sharpened. Was this truly a comet caught in the wrong current, or had something chosen the harder path, a deliberate defiance of gravity's easy flow? The press, ever hungry for metaphor, called it the universe's countercurrent. Economists compared it to a market inversion psychologist, to the stubbornness of genius philosophers, to fate itself. But in observatories the tone was quieter. Engineers recalculated escape trajectories, analysts double-checked the math, and across dozens of screens the orbit line of 3i Atlas glowed red, a single scar of motion cutting against the blue river of the solar system, a symbol of everything that refuses to go with the flow. Was it accident or intention? The numbers alone could not say. But as one astronomer wrote in a private memo later leaked online, it takes energy to go backward, always. And the question that followed hung in the air like static. Whose energy was it? The 48-year echo of the wow signal. For nearly half a century, one fragment of static has haunted the history of human listening. August 15, 1977. The Ohio State University Radio Observatory, known affectionately as the Big Ear, was scanning the sky near the constellation Sagittarius. Its mission was modest, almost monastic, to search the cosmic background for the faintest whisper of something not random. Then, for 72 seconds, the universe spoke. A narrow-band radio burst clean, powerful, perfectly centered on 1420-456 MHz, the hydrogen line. That frequency was sacred in the search for extraterrestrial intelligence, the natural channel of life emitted by neutral hydrogen, the most abundant element in existence. If any civilization wished to announce itself to others, it was the logical frequency to use the cosmic common tongue. Volunteer astronomer Jerry Eman, reviewing the computer printouts days later, circled the sequence of numbers and letters that stood out like a flare among zeros, 6EQUJ5. In the margin overwhelmed, he scrawled a single word that would name an era: wow. The wow signal was never heard again. It didn't repeat, it didn't drift, it left no echo, no coded message. Its direction was triangulated to a small patch of sky between the stars Chi Sagittarii and Tau Sagittarii, a region rich in hydrogen clouds but empty of nearby stars. For decades that patch remained astronomy's holy enigma, the place where something once called. SETI spent years trying to hear it again. They never did. Big Ear was dismantled in 1998, its land reclaimed for a golf course and monument to how easily humanity buries its own wonder. But the coordinates survived. They became a symbol, the coordinates of longing. Then, in late 2025, a quiet calculation in Harvard's astrophysics department lit up the same coordinates in a new light. When Avi Loeb and his team plotted the backward trajectory of 3I Atlas, using its latest orbital data compensating for solar perturbations, galactic drift, and the object's retrograde inclination, the line intersected the WOW coordinates, not roughly, not coincidentally. Within 9 degrees, the same angular corridor from which the 1977 signal had arrived. 48 years apart, two anomalies, one auditory, one visible, emerging from the same celestial direction. Even in a universe of chaos, such symmetry feels like intention. To the SETI veterans who had grown old waiting for a second signal, the discovery was both vindication and unease. They had once believed that communication would come as repetition, a pulse, a message, an unmistakable sequence. But what if the reply was not another transmission? What if the reply was a visitor? Historically, SETI had flirted with philosophy as much as technology. Frank Drake's 1961 equation had quantified probability. Carl Sagan's optimism had wrapped it in poetry. The assumption was that civilizations would call across light years because travel was impossible. Radio was the bridge between stars. No one ever planned for the bridge to arrive in person. Yet here in the cold geometry of orbital mechanics was the possibility that the call and the arrival were the same event separated by time rather than space. If the WOW signal was the transmission, 3I Atlas might be the response. The alignment alone proved nothing. Astronomers cautioned that 9 degrees of uncertainty could encompass thousands of light years. But even the skeptics spoke softly now, their arguments tinged with awe, because coincidence had become a pattern, and patterns are how meaning begins. To grasp the strangeness, imagine the Milky Way as a dark ocean silent for billions of years. In 1977, we thought we heard a single drop of water, a splash so faint we couldn't tell where it came from. Now 48 years later, a ripple arrives on the opposite shore carrying something within it. Maybe it's natural, maybe it's noise, or maybe, as Loeb mused in one late-night interview, it's something subtler. Perhaps the WOW signal wasn't meant as communication. Perhaps it was a breadcrumb, the sound of departure. Maybe they called once, and now they've come to see who answered. The thought hung in the air like static, because if that's true, then the universe didn't just send a message, it sent a messenger. And somewhere beyond Mars, that messenger is still moving its path, echoing across 48 years of silence, carrying the question we've been asking since the dawn of listening. Are we the reply? The psychology of first contact. By December's end, the data still refused to settle, yet the human imagination already had. Governments could stay silent, agencies could delay, but people cannot wait forever in the vacuum of uncertainty. In that void, humanity did what it has always done. When faced with the unknown, it began to invent meanings faster than facts. Some called it proof of God's handiwork, a celestial engineer, arriving at last to confirm creation. Others saw it as apocalypse revelation by orbit, and some more quietly confessed they felt nothing but relief that the loneliness was over, even if what waited beyond was not kind. Psychologists had long warned that the first evidence of extraterrestrial intelligence would not be a scientific crisis but a psychological one. For centuries we have built our cosmology on two comforting assumptions: that the universe is vast and that we are alone in it. Both make us special, both allow us to sleep. To lose either, even hypothetically, is to feel the ground tilt beneath belief itself. Religious leaders moved first. The Vatican Observatory issued a serene statement. If there are minds among the stars, they too are God's creation. In contrast, evangelical networks in the US declared 3I Atlas a deception of the adversary. Islamic scholars debated whether such beings would be subject to divine revelation. In Buddhist circles, the response was gentler recognition without surprise. We have always shared the cosmos, one monk said simply. Faith, it seemed, was flexible. It bent but did not break. Politics was less graceful. National governments quietly shifted their postures from scientific curiosity to strategic calculus. In Washington, the phrase non-human intelligence began appearing in internal memos not as wonder, but as risk. China increased its deep space radar monitoring and began classifying all high-altitude optical data. The European Union established an extraterrestrial phenomena working group to assess security and cultural implications. Even the stock markets moved with anthropology's oldest emotion, fear of the unfamiliar. Investors fled aerospace stocks one day and overbought them the next, unsure whether discovery would mean collapse or renaissance. Because underneath every algorithm, every government, every religion lives the same fragile wiring, the need to protect meaning when meaning itself is threatened. Anthropologists began to draw analogies from history. They pointed to the first Polynesian voyagers arriving on isolated Pacific islands, their sails appearing on horizons once thought empty, and to the devastation, wonder, and myth-making that followed. They recalled Cortez's ships off the Aztec coast, the way an entire empire mistook conquest for divine return. They cited the cargo cults of Melanesia, where isolated peoples, having seen airplanes and radios for the first time, built wooden replicas to summon the gods who had once descended with gifts. Contact, they reminded us, is never symmetrical. The powerful arrive unaware of how much power they carry. The receivers in turn interpret through the only lens they know themselves. We project humanity onto whatever arrives because it's all we have to measure by. Cultural psychologists call the phenomenon cognitive anchoring. When we encounter the unthinkable, our minds search for precedent. It's why early astronomers saw faces in Mars's craters, canals in its valleys, why when a shape glowed near the sun, we saw not physics but purpose. To admit we cannot interpret something is to admit we are not yet evolved enough to. And humility is not our species' strongest muscle. Avi Loeb, ever the quiet centre of the storm, addressed the question in an interview few noticed at first, a late-night panel for a psychology conference at MIT. The first contact, he said, isn't with another civilization. It's with ourselves. The moment we confront the limits of our understanding, we meet who we really are. The fear, the faith, the arrogance, they are all mirrors. He paused, looking down before continuing. We often imagine first contact as a handshake, but perhaps it's more like a reflection of the universe holding up a mirror to see if we can stand to look. And so the global conversation, fragmented and fevered, began to circle that mirror. News anchors spoke of cosmic neighbours, while governments issued non-statements. Forums swarmed with believers and skeptics. Families argued at dinner tables about whether the thing behind the sun was a machine or a metaphor. Yet beneath the noise lay something gentler, a strange quiet intimacy spreading through human thought. People went outside more, they looked up more. They remembered that the night sky was not wallpaper but wilderness. For the first time in generations, billions of us were thinking about the same thing, not war, not profit, but our place. And in that shared uncertainty and that tender collective confusion, humanity touched something holy. Not certainty but connection, not revelation but recognition. Because maybe the most important question was never who's out there, but what will we become if someone finally answers? What building on Mars could mean by the first week of 2026, the phrase structure in Martian orbit had slipped from classified memos into casual speech. It no longer sounded impossible, only premature. What had begun as faint points of light tracked by Chilean and Australian observatories was now described in internal ESA documentation as persistent luminous bodies maintaining relative position within subsynchronous altitude. In plain language, something was holding formation. But what did building actually mean? No one agreed, and perhaps that was the point. The most conservative explanation came first: orbital sensors. If 3i Atlas were a probe, artificial or not, then it made sense that it might leave behind smaller instruments to monitor the region it had passed. Humanity does the same. Our missions to Mars have seeded its skies with a quiet constellation of observers, MRO, Maven Hope, Tianwen-1, each a different eye watching the same world. A distributed sensor network in orbit is efficient. It allows triangulation, redundancy, and resilience against solar storms. If you were mapping a planet for chemistry, weather, or life, you wouldn't send one monolith. You'd send a swarm. And so the first hypothesis was comfortingly familiar. Perhaps the triangle at Mars was nothing more than a mirror of ourselves, a natural strategy played by someone else. The second hypothesis was more daring: resource probes. Mars, even to human eyes, is a treasure chest of accessible metals, frozen water, and trace organics. If an interstellar traveller needed refueling or raw materials for self-repair, the red planet would be an ideal depot. Its thin atmosphere and low gravity make landing easy, and its regolith contains iron, nickel, and perchlorates that could be harvested for manufacturing. Speculative engineers at MIT quietly drafted feasibility models. An autonomous robotic system could mine polar ice for hydrogen and oxygen, process regolith for metals, and 3D print replacement components. The energy required could come from thin-film solar arrays or compact fusion sources technologies we ourselves are only beginning to imagine. If 3i Atlas was truly controlled, then the notion of subsidiary fabrication units, machines repairing machines, wasn't science fiction. It was standard maintenance scaled to the stars. The third possibility hovered at the edge of imagination terraforming precursors. Some analysts pointed to the geometric spacing of the objects, 3 points arranged at equal distance along a low orbit as suggestive of coordinated atmospheric sampling. They weren't transmitting power or collecting light, they were watching the air itself. Theorists proposed that if an intelligent agency wished to modify a planet's climate, the first step wouldn't be construction on the ground, it would be observation from above, to monitor wind patterns, radiation flux, dust density, to decide where to begin. And so a quiet question spread across late-night research calls, what if the project has only started? To separate fantasy from feasibility, scientists compared the unknown with our own blueprints. Human Mars exploration plans for the 2030s already include orbital supply chains and automated staging platforms, small satellites that can relay power and data to surface bases. We too plan to build first in orbit, not on soil. NASA's conceptual Mars base camp envisions a ring of modules circling the planet, supporting human missions for months at a time. From orbit, machines can refuel, repair, observe. Only later do boots or wheels touch ground. In that sense, what we imagined 3i Atlas had left behind was not alien at all. It was the logical prelude to colonization. Still, even among the cautious, wonder refused to die. If the luminous triangle was artificial, it represented technology far beyond ours, structures that could hold steady in orbit without propulsion, perhaps balanced by magnetic fields or gravitational resonance. They would be like invisible bridges spanning space, a lattice of quiet purpose. Astronomers speculated about lightweight metamaterials reflecting sunlight at specific angles, producing the flickering seen from Earth. Engineers pondered self-repairing nanostructures, field-driven frameworks, quantum tethers. Each hypothesis sounded impossible until someone pointed out that everything in orbit today would have sounded impossible a century ago. Even Loeb, usually allergic to poetry, allowed himself a moment of imagination. In an interview with Nature Astronomy, he said, "If the geometry is deliberate, then it's the beginning of something architectural. When we build, it's because we intend to stay." That line circulated online, stripped of context, recited like prophecy. If we build, we intend to stay. And so as the year waned, the question sharpened not into what 3i Atlas was doing, but why there, why now? Every theory, sensor, resource, probe, terraforming precursor led to the same implication: continuity. Whatever the object's purpose, it wasn't transient. It was establishing presence. Perhaps that presence is scientific measurement without interference. Perhaps it's preparatory scouting, seeding building. Or perhaps it is something we don't yet have words for: an experiment in patience on a planetary scale. As winter reached the northern hemisphere, Mars shone bright in the evening sky, a red ember drifting between constellations. People who had never looked up before began to, and some swore that through binoculars or telescopes or even imagination, they could see a faint pulse there, a heartbeat in orbit. Maybe it was nothing but sunlight on dust. Maybe it was the first architecture not built by human hands. Either way, it forced a single breathtaking thought into the world's collective mind: if something is building on Mars, then the future has already begun, and this time we are the ones being observed. The threshold moment. November 2nd, 2025. Midnight Universal Time. For 12 days, the sun had hidden 3i Atlas from every instrument on Earth, an unbroken silence as if the universe itself were holding its breath. Now the moment of return had come. Across the planet, observatories stirred awake like giant animals roused from sleep. In Hawaii, the Keck twin domes opened first, their mirrors turning toward the eastern horizon, where Mars shimmered low and red. The night air was clear, dry salted by Pacific wind. Astronomers inside the control room spoke in whispers, though no one had told them to. A line of monitors glowed with simulation overlays, predicted trajectories, brightness models, orbital ephemerides, all converging on one uncertain dot. At Atacama High in Chile, the air was thinner, the stars sharper. The Very Large Telescope Array powered on in near-perfect synchronization. Laser guide stars painted the sky with amber beams cutting through the cold vacuum between worlds. Someone began an improvised countdown, not official, just human: 30 minutes to window, 29, 28. No one laughed. In Japan, dawn was approaching, but the Subaru Observatory stayed dark under its dome locked in infrared mode. In Europe, the Canary Islands telescopes faced west, waiting for the moment when the sun's glare would yield to shadow. Even amateur astronomers were ready rooftops, backyards, hilltops from Johannesburg to Reykjavik lenses, aligned on the same invisible corridor of sky. They all knew the probabilities. If 3i Atlas had behaved like a comet, it would emerge bright, fractured, scattering dust like a dying ember. If it was what Loeb feared or hoped, it would not flicker at all. It would appear steady, silent, and intact. For months, the object had been an abstraction, numbers, angles, trajectories. But now it was about to become an image again. A shape. A presence. In control rooms from Pasadena to Beijing, the atmosphere felt less like science and more like ritual. Coffee cups went untouched. Fingers hovered above keyboards. Someone dimmed the lights. And then, as if coordinated by some unseen pulse, a low murmur rose across a dozen time zones, signal reacquired. The first telemetry came from Gaia, orbiting 1.5 million kilometers from Earth. Its onboard detectors, shielded from the sun's radiation, registered a faint point of light emerging from conjunction at exactly 0.47 AU. The brightness curve appeared on screen perfectly constant, with none of the irregular flare that betrayed dust or debris. Minutes later, Keck confirmed object visible. Albedo stable. No fragmentation detected. In Chile, the Atacama operators stared at the spectral data forming before them, a reflection spectrum smooth as metal. No coma. No tail. The comet that should have died in the sun's fire had come through unburned. Around the world, chat servers and encrypted channels erupted with disbelief. On social media, the hashtag #threshold moment began trending, a phrase borrowed from a late-night radio host who described it best. We're standing at the shoreline of knowing and the tide is coming in. In Cambridge, Avi Loeb received the confirmation text from his graduate team object brightness unchanged. Trajectory deviation, 0,2 from prediction. He leaned back in his chair, the faintest smile crossing his face. Not triumph, not fear, just the stillness of a man watching a mystery choose not to end. He scribbled a note on his pad. It survived perihelion. If it can survive the sun, what can't it survive? And beneath that, a single word, threshold. As the night deepened and dawn began to spread across the continents, every telescope continued to follow the light that refused to fade. To the naked eye, Mars glowed red as always. But in the data and the numbers, something new was happening, a trajectory bending subtly outward, almost imperceptible but not random. A maneuver, whether natural or deliberate, no one yet dared to say. What they did know was this: after centuries of staring outward, humanity had finally reached the edge of its own comprehension. The instruments kept humming, the screens kept glowing, and somewhere in the thin silence between stars and equations, the universe prepared to answer. The waiting was over. The revelation had begun. The observer's dilemma. In the days that followed the re-emergence of 3i Atlas, one question eclipsed all others, not what it was, but what we should do about it. The object had survived the sun. It moved with deliberation. Its spectral readings were uniform, geometric, and silent. Now, as the first high-resolution images reached the world's observatories, the debate turned inward, away from data toward conscience. In physics, there is a paradox as old as quantum theory, the observer effect. The act of observation changes the thing observed. It's a principle that begins with electrons and ends perhaps with civilizations. Heisenberg wrote that uncertainty is not ignorance. It is participation. To measure is to touch. To look is to alter. And so scientists began to ask themselves, if 3i Atlas is aware, or even capable of awareness, what happens when we keep looking? Is our scrutiny a form of interference, a signal in itself? Philosophers of science met in quiet emergency conferences. One called it the observer's dilemma, the moral question at the heart of all discovery. Does curiosity justify intrusion? Human history offered sobering parallels. Every first contact on Earth had carried the same tension, explorers driven by wonder, leaving chaos in their wake. The same ships that brought maps and telescopes brought disease, conquest, extinction. Curiosity had never been innocent. It had always been hungry. Now, for the first time, the frontier looked back. Three schools of thought emerged. The interventionists argued for action, for an immediate coordinated attempt to communicate. To them, silence was arrogance. They proposed transmitting mathematical sequences or spectral beacons along 3i Atlas's trajectory. If it's intelligent, they said the ethical choice is acknowledgement. To ignore is to deny dialogue. To pretend not to see is to lie. The empiricists urged restraint. Study but don't engage, they said. The data itself is communication enough. They favoured passive observation mapping or spectroscopy, treating the object as a phenomenon, not a correspondent. Their motto echoed the scientific method: know first, act later. But the third camp, the quietists, warned that even study was interference. To them, the danger lay not in the object, but in us, in our need to explain, to catalogue, to classify. Every measurement is a message one of them wrote. Every radio ping is a knock on a stranger's door. They invoked the prime directive of science fiction not as fantasy, but as moral geometry, the duty of non-interference when faced with the unknown. Avi Loeb, ever the bridge between skepticism and wonder, stood at the crossroads of those arguments. In a public lecture streamed from Harvard's observatory, he asked, "When you find a bird's nest in a forest, do you shout into it, or do you wait quietly to see if something inside begins to sing?" He paused, then added softly, "Patience is the highest form of intelligence." The remark was replayed endlessly online, turned into memes, quoted in manifestos misused by politicians. But its essence was simple. Perhaps the most radical act of science is restraint. Ethicists joined the conversation, framing the moment not as discovery but as encounter. If 3i Atlas was artificial, then it possessed agency. And agency in moral philosophy demands respect. Respect means boundaries. Boundaries means silence. To interfere, to probe, to send signals, to follow might be to break an unspoken cosmic contract, the right of the unknown to remain unknown. Yet silence too carries consequence. If 3i Atlas was watching, then our refusal to answer might itself be a message, one of fear or indifference. There is no neutral posture in the act of awareness. Even not knocking is a form of reply. The dilemma deepened when physicists drew the metaphor tighter. Humanity had become the particle under observation. Our behaviour, not the objects, was now the experiment. Were we capable of curiosity without possession, of wonder without fear, of science without conquest? Those questions rippled through think tanks, late-night talk shows and classrooms. Teenagers wrote essays about cosmic etiquette. Monks debated it beside candlelight. For once, philosophy wasn't abstract, it was procedural. In Geneva, the International Astronomical Union drafted a new protocol, the principle of cosmic non-interference. It recommended that all communications directed toward 3i Atlas be halted until consensus was reached on ethical risk. The resolution passed quietly, almost unanimously. For the first time in history, humanity agreed not on what to do but on what not to do. Meanwhile, 3i Atlas continued its silent course, indifferent or deliberate, its metallic skin catching sunlight like memory. It neither broadcast nor retreated. It simply was, and perhaps that was the lesson. In the long arc of science, we have always assumed that to understand is to engage, that to learn is to take. But maybe knowledge sometimes begins where action ends, in the humility of watching, without touching, listening, without speaking, believing that silence too can be intelligent. The observer's dilemma remains unsolved. Perhaps it always will. Because to look into the cosmos is to ask not only what's out there, but whether we are ready to be seen. The story we tell ourselves. In the end, every discovery is also a story. The data may live in spreadsheets, but the meaning lives in us, in the way we arrange facts into faith numbers, into narrative. 3i Atlas had not yet proved anything extraordinary. It had only unsettled us, held up a mirror and asked a question older than astronomy itself. What do we believe when the universe stops behaving the way we expect? Throughout history, that question has always arrived disguised as disruption. When Copernicus whispered that Earth moved around the sun, it wasn't only physics that trembled, it was identity. Humanity had to reimagine itself not as the centre of creation, but as one of its quieter children. When Einstein proposed that time itself could bend, he fractured the straight lines of common sense. Clocks became elastic space, became fabric, and certainty became obsolete. When quantum theory revealed that matter is not solid but probabilistic, that reality flickers until observed, the universe became stranger than imagination, and imagination became a scientific tool. Each time the same pattern unfolded: disbelief, anger, gradual acceptance, and finally wonder. We adapt to new truth the way eyes adjust to darkness, slowly, painfully, and only after we stop blinking. Perhaps Three-Eye Atlas is not another chapter in that lineage, but a reflection of it, the next boundary we draw between mystery and meaning. Humans do not fear the unknown so much as we fear revision. To change the story we tell about the cosmos means changing the story we tell about ourselves. And for all our telescopes and algorithms, we're still a narrative species. We measure reality by how well it fits into language, not equations. That is why the debates about Three-Eye Atlas, its shape chemistry orbit so quickly became debates about belief. Was it natural or engineered, a comet or a messenger accident or intention? Each explanation said less about the object and more about the observer. We see through the lens of our longing. To believers, it confirmed connection. To skeptics, it confirmed noise. And maybe both were right, because both were human. Avi Loeb once said, "Science isn't the opposite of belief. It's belief under discipline." That disciplined curiosity without certainty may be the hardest art we've ever practiced. It asks us to dwell in the in-between, to resist the hunger for closure, to admit that mystery is not failure but fuel. If Three-Eye Atlas turns out to be ordinary, a misinterpreted rock, a coincidence of chemistry, then the only thing it will have proven is how ready we are to wonder. And that readiness is precious, because the capacity for awe, not the possession of truth, is what keeps civilization awake. But if by some fragile chance the object is not ordinary, if it truly carries intent, then all our equations, our myths, our languages, will have to learn a new pronoun for we. The lesson either way is humility. Humility not as surrender but as posture, the stance that lets us look up without bowing down. Because the universe is vast not to make us small, but to remind us that knowledge has no edge. Maybe the story we tell ourselves isn't about contact or conquest, proof or denial. Maybe it's about learning how to listen, and to keep listening even when the silence between stars sounds like an answer we don't yet understand. In that sense, Three-Eye Atlas has already done its work. It made us curious again. It reminded us that science is not a wall of certainty, but a window one that opens endlessly toward wonder. And if we can learn to live there in that trembling space between doubt and discovery, then perhaps the next great revolution won't be in physics or astronomy, but in attention. The quiet willingness to say we don't know, but we're listening. The November Vigil. By early November, the world had become an observatory. From mountaintops and deserts, from cities dimming their lights, from satellites humming beyond the stratosphere, all eyes turned to a single returning light in the east. Three-Eye Atlas had crossed behind the sun and was coming back into view. It was no longer just a scientific event, it was a vigil. In Hawaii, the air smelled of salt and rain. The Keck domes stood open like enormous eyes waiting. Tourists who normally gathered to watch sunsets now gathered before dawn, wrapped in blankets, whispering questions they didn't know how to phrase. The native Hawaiian astronomers spoke of Ho'ala, the awakening, the moment when night hands its secret to morning. In Chile, the Atacama Plateau shimmered with frost. The telescope's Alma Paranalacia aligned across the desert, their dishes motionless against the Milky Way. Quechua technicians who had lived in the mountains since birth left offerings of coca leaves and candles at the base of the observatories, not out of fear but gratitude. The sky had always been their ancestor. Now it felt like it might be speaking back. In India, schoolchildren in Bangalore woke before sunrise, crowding rooftops with improvised telescopes, cardboard tubes, mirrors, binoculars taped to tripods. Across temples and mosques, priests and imams paused their morning chants to look upward. In Sanskrit, the word darshan means to behold the divine. That night, people used it to describe the act of watching a comet. And in Europe, astronomers at the Canary Islands Observatory passed thermoses of coffee across control panels, half listening to Beethoven over low-volume speakers. One of them murmured, "It feels like Christmas Eve, except no one knows what's under the tree." The data pipelines lit up. Every few minutes, another observatory checked in, object reacquired. Stable magnitude. Reflectivity unchanged. The readings came from across the globe: Spain, Hawaii, Chile, Australia, South Africa, Japan. A planetary relay of curiosity stitched together by fiber optic cable and human breath. Even space agencies that had gone silent during the perihelion blackout were now watching again, but wordlessly. No statements, no commentary, only numbers drifting quietly through encrypted networks. The global media fed on scraps. One leaked image, one rumoured spectral graph. Commentators speculated, philosophers preached, comedians joked. But beneath all the noise was a rare and fragile silence, a silence born not of censorship but of awe. It was strange how peaceful the waiting became. People who had never looked through a telescope before began scanning the sky. Farmers in Kansas set alarms to see the pre-dawn glow. Fishermen off the coast of Japan pointed their weather radars toward the stars. In Lagos, a choir performed beneath the open sky singing hymns about creation to an audience that might or might not be listening. In the streets of Paris, people leaned out of balconies, phones raised whispering it's still there. And on social media, a single phrase began trending across every language: waiting for the light. It was as though the entire planet had agreed unconsciously to pause. For one night, human divisions blurred under a shared horizon. Time zones became one continuous circle of sleepless eyes, following a point of light that refused to behave like a comet and refused to go away. Avi Loeb, watching the data from his office at Harvard, described the feeling in his notes. It's as if the universe is asked a question, and the world is holding its breath to answer. Dawn crept slowly over the Pacific, washing the stars from the sky. The first sunlight touched the summit of Mauna Kea, then the Andes, then the Himalayas. Observatories closed their domes one by one, but no one left. They lingered at the glass, still listening as if the next message might not come through instruments, but through silence itself. The vigil was not over. It had only shifted from the eyes to the heart. And as the sun climbed higher, the world exhaled not in relief, but in reverence. A collective breath released into the new day, knowing that somewhere in the deep blue, beyond a question older than language, was still hanging unanswered, waiting for the next night to fall. The final question: who watches the watchers? By mid-November, the numbers had stabilized. No sudden bursts, no radio signatures, no new anomalies, just the quiet constancy of an object circling outward into the black. For the first time in months, the scientists of Earth had nothing left to measure but meaning. And so the story of 3i Atlas became less about discovery and more about reflection. Because whether it was ice or artifact coincidence or creation, it had done something no machine or meteor had ever done before. It had made us look up together. For decades, astronauts have spoken of the overview effect, the life-altering shift that comes from seeing Earth from space. They described the borders vanishing, the divisions dissolving the planet, turning into a fragile blue whisper of home. They return changed their sense of self, stretched to the scale of the cosmos. But what happened in November 2025 was its inversion. Not humanity watching the universe, but the universe, perhaps, watching us. Billions of us felt it. That uncanny awareness that we might not be the only audience anymore. That maybe after all these centuries of studying the heavens had begun to study back. It wasn't fear, not exactly. It was something gentler, the humbling sense that our curiosity had finally been reciprocated. Every telescope, every pair of eyes, every sleepless night spent under that cold, glittering silence, they all became mirrors. And in those mirrors we saw not the face of an alien visitor, but our own reflection in cosmic light, fragile, restless, endlessly seeking. We are the watchers, but we are also the watched, because to notice the universe is to participate in it. To observe is to join the dance. In Cambridge, Avi Loeb wrote his final note of the year. No bold claims, no revelations, just this. It may not matter whether 3i Atlas was built or born. What matters is that it made us aware of our gaze and the responsibility that comes with wonder. He closed the notebook, turned off the lamp, and let the night reclaim the room. All across the world, the excitement had faded into stillness. The telescopes continued their patient sweep of stars. The news cycles moved on. But in the quiet of those who stayed awake, scientists, dreamers, children staring from rooftops, something remained. A soft awareness, a fragile gratitude, a sense that the universe was not indifferent after all, only subtle, waiting for us to learn its language of silence. Perhaps 3i Atlas was nothing more than a comet. Perhaps it was everything more. Either way, it had reminded us of the simplest truth that we are part of something vast, ancient, and beautifully unfinished. That to wonder is to belong. That not knowing is not failure but invitation. So we keep watching not for answers but for the quiet rhythm of existence itself. And if somewhere far beyond the reach of our instruments, another gaze meets ours, then we will have learned the deepest lesson of all, that to be seen is not to be measured. It is to be remembered. And as the last traces of 3i Atlas fade into the outer dark, the world exhales one final time, not with closure but with calm. Because some questions are not meant to be solved. They are meant to be kept alive to remind us that the unknown is not our enemy, but our mirror. Perhaps mystery is how the universe keeps us awake to wonder. Thank you, subscribe now and don't miss what's to come.